And it says you're live. It's showtime. Yeah, let's see. Make sure we get everything all set up here. Looks like we might have audio,
There we go.
video, all that good stuff. Hey, guys. Good afternoon.
Hello.
And welcome to Blue Marble Science on a lovely Memorial Day holiday here in the States. Joining us, we got Alan Evans, Bibby, we got Shikey, Farmer's Boy, and Rob Barton. How you guys doing?
Well, thank you, Bo.
Splendidly.
Yes, indeed.
Excellent. Now we got 42 people watching already. That's good. See a whole bunch of people out in the chat. I'm not going to try to name all of them. But I'm glad you showed up. So what's been going on? Anything good?
Well, other than somebody thinking they can see Mont Blanc from Snowdon in Wales.
Yeah.
Not possible, eh?
Yeah, I trust me. On a clear day, you can see quite away from the top of Snowdon. I've been up there 3 times. But I'm afraid you can't see Mont Blanc. You can't see the Alps from Snowdon. I don't care how clear a day it is.
Can you even see the Isle of Man from top of Snowdon?
Oh, I don't remember trying to look, to be honest. I mean, typically, by the time you get to the top of Snowdon, you're absolutely shattered, and all you want to do is go back down a little bit to the cafe, because they built a cafe there, and get a cup of tea.
Why not go up on the train?
We did the last time. Unfortunately, that's when they're renovating the cafe, and they said, we're going to be stopping at the last stop before the cafe. That's where the cloud started. And I do mean solid cloud. And it was like, well, there's no point walking the last little bit up to the top because we're going to be in the cloud. So that was a nice trip. Let's walk back down.
Yeah.
Bit of a shame, but there you go.
My son used to go up on the train quite a lot, but that's because downhill mountain biking is a hell of a lot better when you've got a train to get to the top of the mountain.
Yes. Yeah. So, yeah, that did make me chuckle when I saw a link to who was it, Taboo Conspiracy. Oh, what this wonderful photo. We actually go and find the original photo and look at it and zoom in. You go, yeah, they're clouds.
Of course they're clouds. They're always clouds.
I think if you use Walt Bislin's Earth Curve calculator, the summit of Mont Blanc is just over 60 kilometers below the horizon.
Yeah,
from Snowdon.
it's something. I did that. It's something like that.
Yeah.
Not
Yeah,
a chance
60
you're going to see that. Not a chance.
No.
You will see some clouds on the horizon, though.
Yeah. I mean, you can see a fair chunk of Wales because that is looking in that direction. That is the mountainous bit. But yeah, off in the distance, no, not a hope in hell.
Nope. Oh, and they've come up with another one too. I just saw a little while ago.
Oh yeah.
This one's got all kinds of strange things. Forgot what that one's about though. Hey, we'll get into that one of these days. Today we're gonna have fun and go over some really silly crap that came out of the guys over at On the Level last week. I thought it might be worth spending a little time and going through this, because what Bev did basically was just go over a debate that he and I had over on his Discord channel one time. It's been probably a year ago. But he's hurting for content so bad, the only thing he can do is just replay shit every day. Same thing.
Yeah.
But it's so full of funny misrepresentations and misunderstandings. I thought might be a good chance to go through it and just have do similar to what he does to other channels, and that is stop it every 20 seconds and replay it 10 times. So get ready.
Please don't.
Yeah, get ready for some boredom, guys. It might get boring. I don't know, but you guys that are here in Discord, you see I'm live in Discord, so you should be able to see my my screen, my YouTube screen, and that's what's going out to YouTube right now. So, with no further ado, and that is sort of the introduction, let's play a little bit of this and see where we go.
Welcome, everyone. A few of you. Good day. This is dedicated to the proofless logician, Buddy. He has he's requested that we go over. I call it the transitive law of equality. That's what I've always been told it was. It's got many different names. Some people don't like to call it a law. Some people just like a property. There's all sorts of different names that people use for this. But it's just if things are equal to the same thing, let me get me Euclid. This on the axioms. Axiom number 1. Things which are equal to the same thing are equal to one another. I think that says it a little bit simpler. But
I can hear the sound on the YouTube, but I
if
can't
A equals
hear it
B and B equals
general chat. Is that what's meant to happen?
You have to click on my live symbol up there, baby.
Okay. Oh yeah, watch stream.
Watch it and hear. Okay. Then you'll hear it. Ready? Let's try it again. See if you hear it now.
equals C. Then A equals C.
Thank you.
More of an algebraic one. I prefer the Euclid. Things are equal to the same thing, then they are equal to one another.
Yes, I will go along with that, Bev. You are correct. Two things equal to the same thing means that they are equal to each other. Very good.
However, let's just note that this was in response to my point that P implies Q and Q implies R implies P implies R. It's transitivity of implication, which he confused with transitivity of identity. That's the first mistake.
Yeah, okay. And I agree with that too. So let's see where he goes here.
The same thing, but this exam with letters, this is example. So this is application, how it works.
Yeah,
example.
I think what a lot of people are getting an idea of is that all of these three things need to be the same, but it's not. This isn't quite like that, right? They're equal to the same thing.
Yes, same but different from the previous one. So we have three things here, and we are comparing two things to third thing, and this third thing is the same thing. in this sentence.
Yes. Yeah, and that's the a transitive law, because you get to make a conclusion by equating you're saying that they're equal to the same thing in a way, so they're equal to each other. In basically, Betty's asked that. Let me get this. I don't know. I can't remember what he called it. So, seeing as his Betty's requested this, I best check that we're getting the right thing for Betty, because no doubt he's gonna go over this, and he does reviews, and he documents all of this sort of stuff. He timestamps it. He tells Blue Marble all of these different points. So get ready. Blue Marble started doing it as well, actually. There's one here about paper.
Yeah, true.
I'll go over that, right? So this says, just one thing for you to discuss tonight. In fact, I'll get it and put it in the chat so you guys can see it. I can't.
Yes, it'd be way too much trouble just to read the damn thing, I bet.
So okay, this is for Betty, in honor of him.
Yeah, thank you. Thank
making
you,
up arguments over there
What? Say what?
at the Blue Marble Science server, and because obviously he gave us the some way to disprove a globe, I think. But anyway, he says, just one thing for you to discuss tonight. The law of transitivity. So I hope it's the same thing. I mean, it says also known as the transitive property of implication. States that
did you get that implication, not identity?
Yeah, say it again, baby.
Yeah, he read out transitivity of implication. He's confusing it with transitivity of identity. Actually, just one other thing. He says there are three things, but if A is one and the same thing as B, and B is one and the same thing as C, then you've actually got one thing.
That's
but
right.
Three different names. One's called A. Well, the same thing is called A. It's also called B and also called C. And that's something paper also confuses the heck out of.
Yeah, that is the point. You are giving the same thing three different names.
Correct. Yeah.
And in order for this to work, A equals B is fine, but B has to be equal to C. B can't be equal to something else. He's about to mess that up in a minute. We'll get there.
Let's go though.
A is equal to B and B is equal to C, then A is equal to C. Do you agree with that law? Yes or no? I replied to him, I've made an argument around that quite a bit ago to Blue Marble, which we will be going over tonight, right? Just in honor of Betty, because in case you thought I was lying about it. No, I mean, it's one of the most basic axioms. It's axiom 1 in Euclid. So that's one of the, I'd say, the first laws. If you were going to make an argument, that should really be your starting point, because it's the simplest thing to explain to anybody, right? It's the most basic logical statement that you could ever make.
For me, this is just the law of identity. So I don't know why this is called, or Bebby is calling that law of transitivity, or transitive property of implication. Property is not a law. Property is property.
I know, but there's a lot of that, you know, if you look into this, new modern science and I don't know, logic or whatever, has obviously had to change laws, because what with diletheism, like, I mean, they can't really say it's a law. They're not allowed, are they? If you're going to drop a little diletheism axiom, right? You can't.
What do you say about that, baby? I don't see a problem
Well,
calling it a law.
He likes to drop in dialetheism. That's what it's called, law of transitivity. What's the problem with that?
I have no idea. But then again, paper is special, isn't he?
Paper's very special, yeah.
Can't go around brazenly stating laws and things like that.
I have objection, formal objection to what he said, because he is equivocating the law of transitivity with transitive property of implication. So he is equivocating law with property. And this is my objection, because law
Objection overruled, paper. Shut up.
is not property. But he is equivocating that. I object.
Let's just point out here that I'm reading from stuff from St Andrews University. Direct proofs also often use the law of transitivity, right?
Mm-hmm.
Also known as the transitive property of implication. This law states that if A implies B and B implies C, then A implies C, which they're still confusing with the principle of the transitive identity, but never mind.
It's going to get a lot worse.
Oh dear, I hope not.
There you go, Betty.
Property is,
Timestamp that
for
one.
example, that cat is white. So he has this property, that whiteness or blackness or whatever color you pick up. So, and this is not law. Property is not a law. Sorry.
And it seems like you may be getting under Blue Marble's collar a little bit, paper, because I look at this. This is all for you. Look at that.
I'm impressed.
Blue Marble's writing you a book.
But he's using big E.
Yeah.
Big E.
And
He's on your side.
Oh, goodness. I did something bad, I guess.
and I don't know in which way he's using a word globe. If
It's only a
shape,
little G.
oh, I still don't know
Yeah.
what he's talking about.
But you should, shouldn't you? Because, I mean, I've heard that a lot, right? You're just feigning ignorance that you don't know what Blue Marble's talking about, because he's obviously wrote quite a lot of words there. And I bet Betty understands what he's talking about. I bet there's a few people over there at the Blue Marble Science HQ letting us know. But anyway, that's by the by. We're going to go back to the transitive law of equality. Did I have... I don't know whether I actually had it on here or not.
Stop mumbling, Bev.
There you go. This is the one that I've been using.
Uh-oh.
I can't quite get that in. So let me click that off. Move the screen back. Okay, so this is one that I did a fair bit back, and it was similar. I mean, a lot of people, this is the sort of, once you first start to formulate logic, I think these are the most simple type of logical processes that you can do, where you relate two things together and then come to a conclusion. Well, obviously, we've got this argument, right? You equate two things to a similar thing, and if in this case an equal elevation.
And that is the flaw in his logic. We'll be talking about that more in just a minute. But that's exactly where he goes wrong.
Yes, because in that statement, if A equals B and B equals C, therefore A equals C. Of course, in this example, we are not talking about letters because A is not B and B is not C and A is not C. So we are talking about similarity in within the thing. So in which regard they are the same. For example, if we are talking about color, then we can say that three different things are equal in regard of color or shape or whatever else. But of course, there is no such thing as same things being different and same, the same individual. So you cannot have three different individuals being the same thing, the same substance.
Can we just stop
So
there?
this
That's a
law,
famous mistake of Bebb's and the others. Sorry.
Yeah, let's go.
Yeah, this idea that A can't equal B, it can't be the same thing as B because A is a different sign from B. I think SE Montreal made that mistake. A equals B must always be false because they're different names. They can't be names of the same thing. And that's what paper is saying there, wrongly.
Yeah. That, well, they've gotten this wrong from the beginning, and they continue to get it wrong. I don't think they're ever going to get it right, to be honest.
But you know, it's fundamental to maths that you have two variables.
Yeah.
Different names, x and y, and eventually after a process you either find that x does not equal y, or you prove that x equals y. That's you can't do maths without that idea. But oh, they can't do maths, right?
Yeah.
It's the interruption.
That would be one of the
I did-
problems.
Add it to the long list of things they can't do.
Oh,
Yeah. All right. He's going to get to it here in a minute, I think. Let's see where we go.
is talking about, yes, property shared by three, let's say, objects. So if they share the same color or shape, we can say that they are equal or the same in regard of color or shape. This is what what Euclid is talking about. So in which regard it is equal or the same. So if we have two straight lines, so they in different position, let's say, or in different location, better to say, they are equal not because of their localization, but they are equal because they are both straight. So they share straightness, both. So they are equal in regard of their straightness only.
No, in the idea of this is that level is an equal elevation, right?
Yeah.
That's the way it is, and as is horizontal.
Yeah. So
And there's the problem. Level is an equal elevation. Horizontal is not. That's the mistake.
they share. Yeah.
So they say a similar property being an equal elevation. They are equal in the regards that they share the property of having an equal elevation. And also, both of them are perpendicular to plumb or vertical. Same thing.
Yes,
Another
so they share
property that they share similarly.
two properties.
Yeah.
Yes.
And probably many others, right? But for the sake of a meme and an argument, I don't think you don't really need to have two. You just what either of them will do. To state in that regard, with them being equal with that property, then they are equal in the sense that they have an equal property shared.
Yes, yes. So it means that they have this inside themselves, this property. So horizontal is equal elevation and level is equal elevation. So they both share the same property. So they are the same in that regard.
Right, now, this, what we're going to watch here now, let me get you in for you guys. I don't want to be wasting any time. I want to try and get into the... this is what I titled The Debate. And it is perhaps one of my most viewed videos. It's got 3,500 views, which for my channel is very good. I have to thank Dave Weiss for that, because I think he's done that. But listen to how I did at the beginning formulating this sort of stuff, and when I hear this back, I keep hearing myself going and it's obviously a fair bit ago, but let me just put this over here. Okay, right, you guys in Discord? Yeah.
Yes, we
Okay.
we are on track.
Yeah, that's muted.
Yeah, that worked. All right.
Okay. So are you okay for me to go
Yeah,
with
I'll
my
go on
opening?
mute. I will go on mute, and it's all yours.
Okay. Welcome everybody. This is the debate done over on the Level Discord server. As we've said, requested by Blue Marble Science. I thank you for giving me the chance to be able to do this. I'm going to treat this as a sort of a dissertation type thing of an end of the study of what we do here. Now, what we do here is called, well, we've named it Advanced Simplicity. What we do is we find a topic or whatever, and we break it down to the most simple that we can. Now, as we do that, we have done it with geometry because of the initiation into this arena that we had was through geometry. It stuck with geometry, but along with that came to the breakdown of the geometry, which led to logic, and then the breakdown of the logic into words. So that led us to the trivium. Now, the trivium is a way to sort of a tool of learning how you process and how the mind works and how you link things together through the identity of subjects and through to the logic form, and then down to finally the rhetoric of how that's portrayed. That's what I'm going to aim to do today, is to give you a chance to have an insight into what we're doing here and what the way this works. So this debate is an idea where you present an argument. Now, an argument, I think a lot of the time, back to words and all of that, has been taken over. It's now come to mean people shouting at each other, maybe body parts being dangled, and you know, other acts that seem a bit strange. But in reality, the argument is a form of sentences that are put together in a way to make the mind do a little bit of work and for you to be able to come to a conclusion. So within what we're doing here tonight, I'm going to attempt to break down and give you an idea of a couple of arguments that I've made in order to deal with Blue Marble. Like Blue Marble wanted the debate, Blue Marble Science wanted the debate about level is horizontal, level is quest ... and all horizontals are ... So I'll give you a chance to try and do that. Let me see, is my camera on there? Or,
He certainly can waffle on, can he?
for you guys.
God, not half.
Bloody hell.
Had to reset.
Yeah, I know.
See, I was doing this live.
Now you're good,
You
Bev.
can see that now. So
Yep.
if I put the whiteboard on, can you see the whiteboard?
Here we go.
Okay. Are you okay with
Yes.
that? Everybody on that? You guys on YouTube can obviously see it as well. Yeah. Okay. So initially at first, I guess you guys have seen this. If you say A equals B and B equals C, then you can say that A equals C. You see that?
Very good, Bev.
Right now, just move this microphone over it. Right, so you can see that these two and these two make this one as a conclusion, right? But what you can say is that this one and this one, that both this and this are the same as this, B. So these two have a common part here. And because both of these have this common part, then you can say that this one equals this one.
And that's true as long as they have a common part. But they have to have that common part, Bev. You can't have A equals B and C equals D and imply A equals D. And that's what you're
Right.
about to do.
It's called the transitive law of equality, but it's maybe a little bit confusing, a silly name, but I mean, this statement here is a basic understanding of a fundamental really of logic and reasoning, and you could say that this is also part of a mathematical understanding through logic.
Bev, if
Yep.
I hate to do this to you, but
What?
how can I'm not able to see your screen.
So you notice here that this is in the middle of the debate, and Blue's got a video done, and he's interrupting.
Well, I had a little technical problem, Bev, and I've seen you have them too. But
Yeah.
I'm not the whiny bitch that you are, so I kind of skip over it. I'll tell you what, instead of listening to Bev whine on and on about it, let me move forward a little bit here and see what we do.
Because you're sharing your screen also.
Yeah, it might be. Let's see if we can find the front end of it.
You say this is the foundations of geometry, the axioms that they go by. These are more common notations. They are in everything really,
just
within
stop-
our understanding,
just
within
stop there.
logic, within.
Oops. What did I
It's
just
not
do?
common notations.
That was a bad
It's
move.
not common notations. It's common notions. It really has got that
Yes,
wrong.
and he's messing orthographic view with perspective. So because this red line,
this law that level.
Hold on a second. I punched the button at the wrong time. Wrong button is what happened. Let me see if I can find it. find out where we were. I want to point out too, while Bev was whining and complaining about me interrupting him, I offered to let him start over again.
On Discord, just click Bev
I
icon
think they can see
and
it, really.
click on that.
They're just doing it to
If you
interrupt,
go
I think,
to
honestly.
Agents of
Yeah.
the Logos,
We know the boomers,
multiple
but
icons will show,
he's
and
got a
click
Discord
on
channel.
Bev. So you will see.
Well, what I see is what it does is take me to the to your YouTube channel.
Grandad,
That takes me to his
come
YouTube
over
channel.
here. Far into it.
Yeah. I'll tell you what I can do, I think.
He was searching in the wrong place.
Technical difficulties are always a problem.
Yeah, with you, Blue. No one else can actually see.
I can't.
If
It
you
might be because you're sharing your screen also.
Everybody can see it. It just came on YouTube, so yeah, we're sharing it now. I'm sorry, Bev. I really apologize about that. Let me get back at. Start over again if you want to. Now, I offered to let the guy start over again because it was my mistake, and he's going to be a little prick about it and complain. I don't know what else to say.
Okay. I'm all right.
We got it going now. We're all good now.
Okay. Yeah, we can cut
So
that
on
out
the,
later. Don't worry.
The statement before, if A equals B and B equals C, then A equals C. We could see that there's a common part. So I'm calling this, I'm saying that the advanced simplicity that we're doing tonight is a lesson from Euclid. So this is Euclid's Elements, you can see on screen now. And the first axiom within Euclid's Elements states, things which are equal to the same thing are equal to one another. Now, you could say this is the foundations of geometry, the axioms that they go by. These are more common notations. They are in everything, really, within our understanding, within logic, within mathematics, within geometry, within numbers, within everything. It's things which are equal to the same thing are equal to each other. Now, that will be the form that I will be taking, well, both of the arguments tonight. To keep it as simple as possible, these arguments will be made around that very fact. So if that's how we break it down to simplicity, then what we're doing is we're taking the very first axiom of the fundamentals of the elements of geometry, which is the elements of mathematics, when you break it down to the logic form. So this is really the elements of logic that we're dealing with. And so that being the axiom, just get rid of that.
Okay, so the idea for me here is to obviously this is a debate, the first chance we get to have a debate with Blue Marble scientists, and I think it's well worth pointing out how to form an argument first, to be able to explain how the argument is formed, so that Blue Marble could go along with it, right? He could get into the flow of exactly how an argument's formed. So that's all I've been doing on this part of the thing, is to, apart from getting interrupted by Blue, just to show how an argument's
What is this?
formed.
Did you have a debate with
Now
Bev
I'm going to
recently or
go
something?
and do the argument.
Yeah, this was quite a while ago, Rumpus.
Okay, right. You're just reviewing a debate you had. Okay. Yeah.
No, actually, Bev did a review of the debate we had last week. He did this review of a debate we had a year ago. So,
right, and then we're reviewing his review. Right. Okay.
Yeah, so we're reviewing the review of the. I don't.
So it's taken him 5 minutes to get round to saying that things that are equal to one
It
another.
really
I mean,
has. It really has, Rumpus. Yeah.
yeah, it's just amazing. I mean, this is something he's done over the last few years. What he does, when he does understand a subject, like something A is equal to B is equal to C, he then spends an inordinate amount of time saying how amazing this is. I'm going to deal with this and go dig deep into this, guys, and then spend inordinate amount of time going over something basically so simple that a bloody child, an infant school child could understand it, to sort of give him some sort of intellectual credibility. And then he'll go on to say, miss something like, oh, well, there's more than one horizontal, presumably he's going to miss it. He's going to say one horizontal is equal to another horizontal or something, therefore not recognising there's a set of horizontals. So, yeah, so he likes focusing on this a tiny little thing that he can understand, and then, of course, jumps over the things because he doesn't understand. Yeah, okay, right,
Well,
great. So, yeah.
All right.
Well, I object the notion that he understands what he said, because he doesn't. Because for Bev, if a triangle is a plane and a square is a plane, then triangle is a square. He don't know the difference between is and equal.
Yeah, is a yes. There's a set. Yes, is a type of. Yes, there's the equal.
He'll make a marvelous mistake right here in a second.
Okay, so right, so yes, I just want to know whether this was something you've been doing recently. Okay, great, thanks. Sorry,
so the first argument, I've replaced A with level, and C with horizontal.
And the wheels are about to come off, Bev. You've just made that error in logic. You have automatically assumed level and horizontal to be the same, and they are not.
Bit of a premise error there, isn't it? Yes, right.
This is begging the question, Bev.
Yes, surely isn't this what he's trying to prove? Isn't this, yes, as I say, begging the question? Surely this is what he's trying to prove, and he's just assumed it.
Yep.
You can't get pretty much more stupid than this. And this is the guy who was just detailing what an argument is a few minutes ago. I mean, he doesn't understand
the.
Say again.
Incorrectly so. He did not say what an argument was.
Oh, indeed, he didn't. Yeah, exactly. I'm saying he claimed.
He can't even say what he's talking about.
Indeed. I mean, if you remember, Beba, you classically, was it a year or so ago, pointed out that what he called T-shirt logic. He thought that A implies B is an argument, failing to include, well, if you have an argument, you then have to say assert A or something.
That's right. They still have not grasped the difference between an argument and a conditional.
Yeah.
As simple as that.
And so I'm just pointing out that he was lecturing you on what advanced simplicity and what an argument is, and he doesn't even know what an argument is. And as you're saying here, he doesn't know what begging the question is. I mean, it's just, come on, baby.
Yeah. Well, here we go.
So all we have to do really within this form of argument is find a common element that both level and horizontal have in common.
He really doesn't know what an argument is, does he, at all?
I would say equal.
Why isn't it?
Equal elevation.
Sideways.
Now, I think everyone will be able to agree. Level is definitely an equal elevation.
Which we agree, right? We all agree that.
Yeah.
Yeah, that's a premise that we agree on, yeah.
Sure. That's by definition. Level is equal elevation. Absolutely.
Exactly. It is a definition, yes. That is a definition of level.
Defined to be that. So I have no problem with that. Level is an equal elevation. Keep going.
Notice he's talking about an argument. Where is the premise? He ought to have a premise. Level is equal to elevation. And then say, well, should we discuss this? Are you happy with this blue? No sequence of lines of logic or anything in this. No argument at all.
There are no numbered premises and no conclusions so far.
Yep.
Hey, sorry to interrupt, guys.
Oh, hello, Montreal.
What's up, Rumpus? You're the reason I came in. I just wanted to ask you if I can, what's up with the test? Are you still on?
I'm sorry.
Hey, we're right in the middle of a stream here. guys.
Sorry, just I'll quickly answer in blue. Yeah, sorry,
Yeah,
SE. Sorry, SE. I will get onto it. I will keep you informed. Sorry, I've just had a bit of life interfering with things.
But this
I'm
is
still
not
doing it.
this is not the subject of this
Indeed.
evening's.
So,
All
yeah,
right, sorry, guys. I couldn't resist. I heard rumpus. Okay, sorry, guys. Carry on.
It's very nice of you to give me your damn permission, Montreal. Please don't do that again.
However, not
Jeez,
many
Blue,
people
why you
talk
so
about that,
upset?
right?
You're going on mute, buddy. Mute yourself, or I'm going to mute you.
Now,
he did apologise, I
also,
think, didn't he?
Horizontal is
He's just a sore ass.
well, an
rumpus.
auto level would
Don't
produce
SE.
a horizontal plane.
Be quiet.
Just hang on a second. There, that takes care of that shit.
Yep.
And that horizontal plane would have an equal elevation. You would measure a difference. So horizontal in that way would be an equal elevation, and level would be an equal elevation.
Okay, now that's the problem. Horizontal is not an equal elevation. It is not defined to be an equal elevation.
Yes, only in Bev's world.
Yeah, I mean, he hasn't put it as a premise. I mean, he cannot. This is a guy again. He lectures us about an argument, and he has not put that as a premise, as what the premises are here. I mean,
No, because he has already made the assumption that level and horizontal are the same thing. And
yeah, but you put that in a premise, farmers. That's the way you structure an argument. You say this is a premise I'm working to, and then I'll develop it from there.
Yeah, we know that, but this is Bev.
Yeah,
Bev
exactly. My
doesn't
point.
work like that. He has already predetermined that level and horizontal are the same thing, and that's an end of it. You know,
Yeah,
that's it.
Yeah, exactly.
You
And the
have to
problem is
accept that and move on.
exactly, and presumably he's going to end up trying to prove that. I can't remember this debate, but he presumably he's going to end up trying to prove that, which is the most amazing piece of begging the question ever.
Well, isn't
I've
he
never
trying
seen
to
him try
say?
prove it.
Isn't his first premise level is equal elevation, which we agree? The second premise is horizontal is equal elevation, from which he will then be able to prove that level is horizontal. Isn't that the structure of his argument?
Yeah.
Oh, sorry. Yes, you're right. Sorry. Yeah, you're
Which
probably
would be a
right.
valid, as I said, it would be a valid argument, but there's a sort of a wrong premise there, isn't there?
You're right. He's going to end up saying level is horizontal.
Yeah, that would be his conclusion.
Yeah, it would be a legitimate argument if horizontal was an equal elevation.
Correct. So it's valid but not sound, as
Right.
we say.
Right. Exactly.
So that wouldn't work. The equal elevation of a horizontal would be zero slope, no tilt either way. So therefore, horizontal is definitely an equal elevation, and level as well. So, in order for you to make a nice logical statement like this,
Hang on, can we stop
link.
there? Because he has brought in. You're meant to have a middle term, which here would be equal elevation, but he's now brought no tilt in it. Did anyone spot that?
Yeah.
Something has no tilt. Is it horizontal or is it equal elevation or what?
That's another premise of his. Yeah.
That's another premise. Something with no tilt. I think he means a horizontal has no tilt, doesn't he?
Yeah.
Then you've still got to prove that something with no tilt is of equal elevation, which is not true.
Well, did he need to introduce that? He's not actually basing anything. He was just trying to describe what horizontal was, and although he did introduce that with equal elevation, I think he's.
Yeah, but logicians get upset by people bringing in irrelevant terms.
Yes, I agree with you. It's not. Yeah, but we haven't even got an argument here, have we? I mean, I mean, you're right to bring in any error that he makes, but this has no foundation in anything, has it, at the moment?
Rumpus, you have to understand he is completely ignorant of the subject matter.
Yes, exactly. I mean, that's my point. My point was earlier that he's lecturing Blue on logic and argument, and he has no understanding of those two subjects at all. Blue has clearly got more understanding of those subjects than he has.
Yeah, but Bev doesn't know that. He doesn't know.
Yeah,
He has no
indeed.
understanding of the subject.
What? He's too stupid to realise how stupid and ignorant he is.
Quite, as they say. Yes. Shall we move on? Sorry, I interrupted.
Yeah, hang on a second. I want to show
I mean,
something.
it's the classic Dunning-Kruger, isn't it? He thinks, because of his own opinion, his ignorance has enabled him to decide that he knows more about this subject than Blue, and will lecture Blue about this, which is just...
Yes.
Yeah, I mean, so it's classic Dunning-Kruger.
I'll move my Discord over here for a second. I don't know if you guys will still see this or not.
Gone white.
You're still looking at a page of Beb's YouTube channel on streaming.
Yeah, I think this is not going to work the way I wanted it to, but because I wanted to show some things.
Well, take your time, Blue. There's no rush, is there?
Yeah, no.
I see it on the YouTube.
Yeah, you'll see it on YouTube. I need to.
Will we?
Oh,
right,
see what you're trying to do. Yes, we can't see what you're showing on YouTube.
Yeah, you'll be able to. Let's see.
Won't they stop timing Mr. White Benger out?
I think. Yeah, I don't think there's any way for me to show this, but that's what Bev was. It's just a repeat of what Bev is saying. If A equals B, B equals C, then A equals C. Transitive property of equality. Okay, got that. But then saying B is level, that's fine. But also saying B is horizontal and saying B is also equal elevation, that is the flaw in the logic. Level is an equal elevation. Horizontal is not. Now, you can find all kinds of colloquial definitions of horizontal if you want to look through, comb through dictionaries and things. But you can also go on the internet and you can find drawings like this. And you can find hundreds of them, clearly showing level as an equal elevation, but horizontal as a straight line perpendicular to a vertical, which is a radial line. There's two examples of it. And in fact, let's see if I can get this thing to go. There we go. In fact, there's a page out of my 1965 edition of Davis, Foote, and Kelly, which is one of the best surveying texts out there. And it also shows the same thing, level being these nice curved lines following the shape of the earth, and horizontal clearly labeled as a straight line, not a curved line.
Can I dare to confuse the issue, Blue? Would you mind if I introduced a very problematic, confusing thing?
Okay, go ahead.
Verticals are not necessarily radials. Because of the sort of mountains and things, actually, verticals can actually be a bit curvy.
Yeah, they can be, and so this is the very simple version of it.
Yeah.
If Earth were homogeneous and we didn't have the gravitational variations that we have from place to place, then everything I'm saying is true.
Correct.
Now, there are minor differences in the direction of gravity.
And in most cases, that deflection of the vertical is below the instrument's accuracy, a survey instrument's accuracy.
Yeah.
So it's kind of in the noise of all kinds of unknowns.
Yeah,
it's a really tiny factor, but I just wanted to say that if you assert by definition that vertical is a straight line, you can get into trouble if someone knows a little bit of the subject. But in principle, in practice, it is a straight line and it's a radial.
Yeah, I'm glad you pointed that out, because that is quite true. But that's because the Earth isn't perfect. It's
correct.
It has differences in density, and gravity varies, and the centrifugal force is different depending on where you are, and that force is not radial. That force is acting perpendicular to the axis of spin. So all of that confuses everything a little bit.
And indeed, that's a bigger factor. The fact that verticals don't point to the center of the Earth. So, for instance, if you are 45 degrees or so, the bulge causes it actually that vertical. If you extend that line, it won't quite hit the center of the Earth because of the bulginess.
Yeah.
Well, it misses by a lot, actually. It's
yeah,
the
indeed.
deflection is about 7 arc minutes.
Right. Okay.
Yeah.
That's a lot.
But locally, over a few hundred miles, there's not a lot of difference.
Yeah, like in the surveys I've done in my valley here, I measure portion of sphere. There is no point in A and B semi-diameter biaxial ellipsoid in only a half a degree by a half a degree of great circle. And yeah, there's mountain ranges, and yeah, there's some seconds of vertical angle. Yeah, it's square root of fuck all.
But Blue, you said about over a distance of a few hundred miles, there's not much variation. But yes, but the vertical for that over that period of 100 miles is going to miss the center of the Earth if you're say at 45 degrees latitude.
I believe the intention there was a few hundred square miles.
Yeah.
Yes, but my point is that over that period, I'm not talking about the variation over that, says Grandma. The point is that all the verticals will not hit the center of the Earth over that
They measure a portion of they return a portion of sphere, which may not be completely concentric with geoid or I'm sorry, ellipsoid, but they are a portion of geoid. Yeah. So what?
Yeah. Well, you've got to be careful. But I mean, two things. I've said it in the past. That you things like you say, if you say it's radial, for instance, if you say verticals are radial, well, it very nearly is, but not quite. And verticals are straight lines. Well, very nearly, but not quite.
Okay. Just like the radius of the Earth is 3960, right?
Yeah.
That almost never happens.
Yeah. I mean, real life is really complicated, and Bev doesn't understand the simple bits.
Yeah. Well, that's just it. We can begin with simple bits, and the first approximations are still 3960-mile radius sphere, and then you get a little more into it, spheroid, and then you get a little more into it, geodetic, and you get a little more into it, ellipsoidal, and you get a little more into it. Yeah, all kinds of things. Astronomic coordinate at latitude and longitude versus geodetic latitude and longitude. Yeah, and if at the pedestrian level, at the first order level, at the BEV level, yeah, you're not going to sweat the difference between astronomic latitude and a geodetic latitude.
Yeah, I mean, I'm just being a bit naughty there. Just pointing out that if you make just be careful. You're making assertions like vertical is a straight line. To the first approximation, as Shubil says, that's correct. But be careful not to sort of impale yourself on something. If someone says, are you absolutely sure about that?
Yeah, you can be over pedantic and kind of destroy the whole tenor.
Yes, exactly. Because you want to capture
I will impale myself on the hanging of a plumb bob hanging straight.
Wait, hold on. Just let a flat earther quote from a geodetic book. Let them do it. Why are you worried about it?
Yeah, well, I was just worried that statements like vertical is a straight line, and
is a straight line,
are radial. You've just got to say. I mean, obviously, I think someone who's just saying that you want to get as Alan was saying or whatever. You want to make them understand the first order issues.
No. It is a straight line. It is a straight line. If they want to bring a geodetic book that says it isn't, be my guest.
Yeah, and be my guest. If right in the middle of talking to a flat earther about vertical, and you say yes, but it's slightly curved and all this other shit, then yeah, they will impale you on that hanging.
Then they will have you. My principle is that anyone who raises these, they're not pedantic but detailed objections. Anyone who raises those will already understand that level is not horizontal. Therefore, anyone who does think level is horizontal will not raise that objection. Just leave it.
Well, actually, saying that
the objection that they will raise is that we are making ambiguous descriptions at face, and therefore we don't know what we're doing. We have to invent all these little things.
I completely agree with you, Bebby. If you're explaining something, you don't want to confuse the issue by introducing lots of noise and other irrelevant, basically irrelevant
That's
detail.
absolutely the worst
So I
way to
totally
teach.
agree with that.
You
But
start with first principles.
Exactly. But I just want to point.
You may
What I want
mention
to point.
these are approximations.
Right. But SE
you
Montreal,
start
for
with the simple
instance.
stuff.
Oh, sorry, there's a horrible lag here. SE Montreal, for instance, has raised the subject of verticals not being radials, and he because he's picked it up from what other people have said. So he actually knows that not all verticals are radials and not all verticals point to the center of the earth. So he actually knows that. It's one of the things he remembers. So you've got to be careful if you're talking to someone like SE Montreal that you don't just say that all verticals are radials and they all point to the center of the earth, because he will then say, well, hold on, I've heard from someone that it isn't, and he will be correct. And then you get yourself into all sorts of trouble if you assert that dogmatically and say, well, for the purposes of this discussion, it's correct. So you've got to be careful. That's all.
That is true, but I was always say if they raise that objection, then you say, well, why do you think that? Why would radials not be completely straight?
Right, because someone told you so. Who's that guy? Do you know him? Is he a certified surveyor? Play their game.
Well, the thing is, of course, they try and pick up on those little things like what's the other one? Something to do with Einstein. I can't remember now. But they because that's the things they latch onto, and so you've got to be careful not to be caught out by someone who just has a tiny little bit of information that invalidates. I mean, for instance, I think I caught some debate with the Blue and Blue accidentally saying that horizontal, level. I can't remember now what it was, but he didn't get it quite, and Bev leapt on it, and so you've got to be very careful not to. Be totally dogmatic and say this is for all practical considerations, this is the case. I think it's got to be what it say. So I agree with you, Bebby, totally about not introducing things that are just confusing and confuse the message. But you've got to be careful not to get caught out and impaled on someone actually who has heard a little bit of detail that you want to get right.
Rampos, you're not caught out. They are caught out. They will have to admit it. Do you believe this guy? Do you believe what he says is true? So you have to believe everything he says.
Well, no. What they'll say is you've got a different. You're not agreeing with the surveying. So what they'll say, they don't have to believe that that's the case. What they can say is if you declare that vertical is a radial, and they say, well, hold on, I've heard some surveying books or some other guy who's a surveyor saying it isn't. So are you lying, or are you in disagreement, or what's going on? So then you confuse the issue.
You heard me, and you heard them. Who you believe?
Well, they say therefore you're not being consistent. Therefore you're both wrong. Or something along those lines.
We say, and therefore, to cover it, we just say normal to the geoid.
That's a good one.
Yeah. Should we get back to the video?
Yeah, sorry, Blue.
Well, that would be very nice.
Linking level and horizontal to an equal elevation is, well, provable. I think this is something that's a natural thing. Everybody should know this. Very simple, ABC. So level is an equal elevation. Horizontal is also an equal elevation. Then for level is horizontal. Very simple.
There is his argument. It's a valid argument.
He thinks it is.
Yeah, except this little thing he said.
It's perfectly valid.
Yeah, but
Farmers, Bebby's using valid as in the logic, as in the logician sense, rather than valid as in in a colloquial sense.
No, that's fine.
Isn't equal elevation.
But he said I think it's provable. Go right ahead.
Yes, because until now he hasn't proven anything of the sort. He just makes the claim that level is horizontal.
Yes,
and that it's provable.
So the argument is not sound because one of the premises is false, but it is valid in the sense that valid means, which is the conclusion follows from the premises. So if level is equal elevation, and if horizontal is equal elevation, which it isn't, then it follows that level is horizontal. That's all I'm saying.
Right.
It's valid but not sound.
Right.
Yeah.
And he declares level is horizontal, so he needn't even leave his basement because he's already mad at his conclusion. So any field observation is moot because he will just say his field observation returned level is horizontal. So all he did was make a demonstration, which was nebulous and ambiguous, inconclusive, and fractional.
That's interesting actually point you make there, because he talks about this realizing Euclid test, which is testing a bit of abstract geometry. So what would happen if your test that you did in the field disagreed with the Euclidean statement? Which would then be correct? Obviously, it would be the Euclidean thing because the Euclidean defines it. You made an error in your real life thing. So he doesn't know when to get out and do measurements and when not. And to test Euclid, you do not want to get out in the field. You want to get out a piece of paper or try and approximate the logic that using Euclid.
It just goes back. It goes back to where they say spherical trigonometry doesn't even exist.
Yeah, indeed, that's incredible.
Again, I won't just do that. So let me go here because I'm
that my job
been
doesn't
getting
exist.
some.
Yeah, sorry, Tiny. You're superfluous.
Would we have
spherical,
lasers?
Geometry doesn't exist. My job doesn't exist.
Yeah, that's what I gathered. That's what you meant. Yeah, we're saying, yeah, sorry. You've been abolished by Bev.
Oh, again. Oh, how bad.
Hmm.
Okay, so always argument first, form of argument first, and then back it up with as much stuff as you can. So here we go. Can you guys see that? Is that?
Well, I'm going to stop for a second. Because Bev himself has managed to show us, and again, you guys are going to have to watch YouTube if you want to see this, but these observations that Bev makes are wonderful demonstrations of why level is not horizontal. His Blackpool Tower observation, where he's got an auto level sitting on that beach at Southport, just a few feet above sea level, less than 10 surely. Yet the crosshairs of the auto level are striking the building at Blackpool at 95 or 100 feet above sea level. That is very nice evidence that level departs from horizontal. I have no doubt that the auto level is generating a horizontal line, horizontal plane, if you wish. But that's not what we see in terms of the elevations. That horizontal plane is not at a constant elevation above sea level. And then he's done it again at Bedford. This is a combination of two of his pictures. One is up he was fairly close. That's the darker colored trees. And I've overlaid a picture from his auto level, taken from the bridge up at Welney. And the crosshair is way the hell above that bridge, 20 feet or so. His auto level was sitting right at the handrail. So there's two great observations that make you say, something is not right with this horizontal and level thing. These two things cannot be the same.
Yeah, I do like that one at Welney. You know, he's and then there was all the nonsense. Oh, as soon as you put a camera or a phone or something on the back of the auto level, then that throws off your observation.
Jesus
Christ. I want to see a citation for this.
Citation for what?
It's because he knows he shot himself in the foot again.
Well, he's very confused about how an auto level works, of course, because he claims, well, he says that because the line that forms the graticule is very close to the lens, therefore that it doesn't show you horizontal extending infinitely. He doesn't understand how an auto level works. He doesn't understand.
Auto level for?
I know. I mean, it's just incredible. This is a guy who goes on about auto levels, who goes on about arguments, and who goes on about logic, and doesn't understand any of these subjects.
Yeah.
It's just amazing.
I would still like to point out to people that he's the only person in this arena who's got a qualification in surveying.
It was a GCSE, wasn't it? So that's
Well, the only only guy that I know that's got a qualification in surveying and doesn't know how to use a theodolite.
And we've got someone who's qualified in surveying in the panel here, of course.
Yeah. In all honesty,
I was actually talking to Bev yesterday, and he asserted that again about the thing where as soon as you put a camera or something behind the auto level and look through it, it invalidates the observation for some reason.
Well, it does if your photo shows Earth curvature, yeah.
Exactly.
Yep. Let's see what he's going to bang on about now.
Are you guys seeing that, or is it because
an
it's
ISO word?
ISO, yes.
Yeah, we're seeing it. It's
Okay.
clicking in and out, but we're seeing it.
I wish I could say it like a SE when I come round to this. So ISO is a word for a contour line, and a contour line connects points of equal elevation.
He's right.
Like I just said, equal elevation. That's our nice connecting word. So a contour line or isoline connects points on a map that are of or equal value. Examples of contour lines or isolines are isobars or isotherms for pressure. Perhaps the prototypical example of a contour line is that which connects points of equal elevation. So here we have a contour line that is also an equal elevation.
I'm confused at how he thinks that helps him.
Mm.
How does that strengthen his argument one way or the other?
Because he doesn't know how to form an argument. He just thinks if he can talk about something he vaguely understands, that, as I was saying earlier, adds to his intellectual credibility. And they say by talking about these things rather than the actual argument, he thinks he's making progress.
Yeah, he just shows off.
Yeah.
But shows off with things that, as I say, children understand. Things equal to one another, what ISO means, what a contour means. And he's shockingly here is telling us that contour lines join areas of equal elevation. Oh, thanks for that, Bev. None of us knew that before. Well done.
What else does he think they do?
Yeah, the very definition of what the damn thing is.
Exactly. So he's just
You're just repeating the definition. Well, he does it all. He'll do that all the time, though. A triangle, a figure with three sides, the internal angle is equal to 180 degrees. He does that shit all the time.
Yeah, because it's the only thing he can talk about.
Right.
There are some simple things that he can understand what equals means, although actually, as Chaiki said, actually he doesn't understand the difference between equals and members of sets, dealing with sets of things, and is a. So he doesn't even understand. He doesn't understand anything.
Just let him keep going for a minute.
So it's another one to add to the group, but we're just talking about level, horizontal. But at the minute, we could put in equal elevation into it, and then there's a study here. This word is great. Iso-ipsi, I think, something like that. Iso-ipsi, ipsis, something. I don't know. SE does it best. Go on.
Iso-ipsos.
Yeah, there you go. Listen to that, and that means equal height. So that's the word that we're dealing with. ISO means equal, and ipsi height. So I've got some more here. This is a mathematical thing. It's a bit slightly off there, but so this is a contour line, also known as a level curve. For a given surface is the curve of an intersection with the surface of a horizontal plane. So a contour line is a connection of a a line, a level curve, a point of equal elevation where it intersects a horizontal plane. So there's another link for the horizontal plane to the equal elevation. And then this is the mathematical graph to show you, you know, how it works. I mean, everybody can see and knows what a contour line is, but the contour line is a line of equal elevation and where that intersects a horizontal plane. Horizontal plane, equal elevation, a line of equal elevation.
Hang on, how do you get there?
Yeah, that's.
Well, it was. It's in the. Yeah, the definition was a bit. Something could do with reading that definition he was using there.
Well, think about the implication of that. How does a horizontal plane intersect these equal
Something that's not
elevations?
horizontal. Yeah, I mean,
and
yes,
form,
you could,
and form that picture you're looking at.
Well, of course, all the contour lines do form a plane. Of course, they are in a plane. All contour lines do form plane. Is that what that's saying?
Yeah.
A horizontal plane. Sorry, horizontal. Yeah, horizontal plane.
No, do they, Rumpus? Are you sure?
No, you're right. You're absolutely right, Bebby. Of course, they don't. Sorry, no, you're well corrected there. Because of course, all things of equal elevation do not form a plane. That's the point I was making earlier. Yes.
Well, they could if something is perfectly round.
Yeah.
They may intersect the equal elevation.
Correct. You have a great big contour line from, I don't know, Southend up to John O'Groats. That is going to be equal elevation everywhere. It won't fit into a plane, will it?
Well,
actually, it says it could. Yeah, it could.
Well, always. No, not well, the contour line. If you've got a contour line that goes all the way from Bognor to John O'Groats, that is going to be curved.
It is, but it could lie in a plane. It could lie in a vertical plane. Let us suppose it lies on the Greenwich meridian, and it's of equal. It's on the Greenwich meridian. It's equal elevation. Then
it's not a horizontal plane, though, is it?
No, not horizontal. No, it'll
be
it'll be on the Great Circle.
Yes, and that's what we were talking about, horizontal planes, weren't we?
We were talking about horizontal planes. Yes.
Yes. So yes, but you're absolutely right to bring me up there. Yes, I was just sort of leaping on there with the fact that yes, the contour lines actually do not form. So yes, this is what definitions confuse me. So yes, indeed, points on on the contour lines do not form a horizontal plane. I'll take back what I said earlier. They do not form a horizontal plane.
I hope they're not listening, Rumpus.
Yes,
but one thing, did nobody notice that Bev actually said that the line of equal altitude will intercept on a horizontal plane? That means it will intercept at one point.
What is that? What is that?
He actually said that the line of equal altitude will intercept with the horizontal plane. That's what Bev just said. That normally is that it intercepts at one point. That means that the line of equal altitude is curved and the horizontal plane is not. He actually said it.
It'd be more than 1 point, yes. So what is that? I'm just going to try and find that page. It's confusing.
He didn't say it. It's just the same. He said it intercepts. Intercepts means 1 point, I guess.
So what point is Bev making then?
I don't know.
Yeah, I don't know either.
I have no idea what he was trying to.
I have no clue, but he actually, said our point.
The biggest problem that I have with
the example of the contour lines, and these are like horizontal slices depicting the.
And indeed, of course, they're not. They are level surfaces.
They're not horizontal slices.
Through the put that back on.
No.
Through the linking of level, equal elevation, horizontal plane is also an equal elevation. You could say through this law that level is horizontal. I think
He just made a
I'll keep
law
it
out
quite
of it.
simple. I mean, that's the basics of that particular argument, really. I mean, it's pretty simple and it's pretty self-contained within that, right? So that's level is horizontal sorted. Now, okay, what does everyone think of that? Would you be
Well,
confident in presenting that as an argument?
Yeah, of course. If level is equal elevation and horizontal is equal elevation, therefore level is horizontal.
Unfortunately, horizontal is not equal elevation.
Yeah.
So you got a problem there, Paper. Sorry, buddy.
Yeah, someone donates spine for paper because he don't have a spine. Paper, whatever Bev will ask him will agree. He has
Yes,
no
he will.
spine.
Even if they're opposite things. But we sort of have more of an argument now because he's now justified. Now, why is horizontal equal elevation? Well, we now have the contour line argument. So he's saying here is a contour line. All the contours are equal elevation. They are slices. They are horizontal slices. Therefore, horizontal is equal elevation by the contour argument. But he's missed something important there, hasn't he?
Yeah.
Yep.
He's just, because contours are just simply points of equal elevation, he's just simply saying horizontal is equal to
yes, yes.
level again.
Yes.
So he just rephrased it.
Well, he's begging the question.
Yes, exactly, which was what it
the
said at the very start. Yeah, I mean, we contour lines, as it defines, are points of equal elevation. And he said, "Oh, look, because these contour lines are horizontal,
Yes.
therefore."
Yes.
But no, you've just simply reworded. Points of equal elevation are horizontal. No, you've just repeated the same claim.
Yeah, the same clock here he's threw out. And that's the problem. He's got A equals B and C equals D, therefore A equals D. No, I'm sorry, Bev, it doesn't work like that.
Simple.
Yeah. Equal height, Stefan. That's exactly what we were saying. They're called contour lines on maps. And exactly what they show is a horizontal slice.
Good afternoon.
Good afternoon.
It's nice to see you on the whiteboard.
It's nice to what?
It's nice to see you on the whiteboard again.
No, that's old. That's from when I was doing the thing with Blue.
I know, but it's nice to see you on the whiteboard
Good,
again.
isn't it? Yeah, yeah.
It really hurts their feelings when you draw it out for them.
Well, I think, as far as I was doing it, we like to have this approach, the advanced simplicity. Break it down, make it as simple as possible. Like, I probably could have presented it a bit better, could have had some better graphics and stuff, but for simplifying
It's advanced
an
stupidity.
And
that's what it
explaining
is.
how to do it.
Yeah.
I think I did quite well.
Oh.
But for Betty wanted me to go over it, so I think I've already done it. I don't think I could do much better than that.
Let's call it efficient stupidity. Bev doesn't waste any time getting it wrong.
No.
Oh, he does. He wastes a lot of time getting it wrong.
Actually, does. Yes, very true.
Write a meme.
I disagree with Blue.
Make a little.
He doesn't.
Lot of time getting it wrong.
He doesn't waste any time starting to get it wrong.
I don't think
he gets it wrong quickly, and then he spends a lot of time reaffirming
being wrong. Yeah.
He's straight in there with getting wrong. I mean, his first statement on here is wrong, and he just carries on being wrong forevermore, even more.
His second one. His first statement was level equals equal elevation. So.
All right. Yeah, he's got it wrong all the way through. So.
Yeah, he's thoroughly wrong in every regard. Yes.
Yep. We'll keep going.
In fact, actually, he when he gets something right, it's actually odd that he's that bad That I mean, getting he couldn't really get the level is equal or equal elevation as wrong, because that's how it's defined. I mean, even if just go to a definition, it says that, and we all agree on that one. So that was a very difficult one to get wrong. But everything he even tries to do, it's got a remarkably high incidence of getting it wrong. It's quite extraordinary.
Let's see if he's got anything else.
The example of level and horizontal being an equal elevation. I don't know whether Betty's out there or if he's watching. He'll probably watch tomorrow morning. So that's one argument. And I don't know how much what time have we got? Are you all right watching for another one, for hearing the other argument, for presentation? And then you might want to hear Blue's presentation as well, his video. That's interesting, especially at these times. So, yeah, we're going to continue, right? So I'm still presenting live here. Just given that one argument, now I'm going to go for another one. The other argument. We've been talking about this for quite a while. We went back over it for quite a bit ago. We've got all horizontals. We called this t-shirt logic because it was the first one that we ever did. The first logical statement that we ever did to be able to simplify a if-then statement, because it was a bit popular a few years back, modus tollens. But modus tollens is an argument to the negative, where you go over it. So you say it's not something. So we want it to be more positive. So we
made up shit. That's what we did.
we went with again Euclid in order to build the framework of the argument. We used Euclid to show us the way to build a well-framed argument. So this is the building blocks of another argument, and you'll see the commonality with the bit before. So Euclid states, proposition 30, book 1 of the elements. It states straight lines which are parallel to the same straight line are parallel to each other. Meaning that if there are two straight lines and those two straight lines are parallel to another straight line, then they are parallel to each other. So you're basically saying a similar sort of statement as you were before. Two things are similar to something else, or they are the same as something else. Within geometry, you could say parallel is a similar relationship. Once you have one line parallel to the other, then they are in that similar relationship. So that's the Euclid one, and obviously that gets proved. There's a QED at the bottom. It means it's obviously provable for you to be able to do that. So the form of the argument, straight lines which are parallel to the same straight line are parallel to each other. That form of argument is obviously well backed within Euclid. So what we do with that form of argument is we relate it and change it to some sort of reality, or we link it to reality.
He slapped over his diagram, has he, onto this proposition?
Yes, that's a crime. What he just did.
Yes,
and we have a GIF.
Yeah, he's trying to make it look as though Euclid has said this. What is gibberish?
Yeah, gibberish.
There we go. So,
I mean, again, he's just going over the fact that A is equal to B is equal to C. I mean,
the idea behind this
well,
was
this is
to
parallel.
make logic so
parallels, which is fine. That's true.
Yeah, indeed, it's true. Yes, no one disputes A is equal to B is equal to C. Implies that A is equal to C.
Yeah,
No one's disputing that.
he talks an awful lot about things that are correct, and then a very short time about things that are completely wrong.
Well, that's exactly what I was saying about 15 minutes ago. He spends to give himself some sort of intellectual credibility. He will pick on a subject that's really simple that an infant wouldn't disagree with him, and then he goes on and on and on and on about it. And then, having developed that, he'll then suddenly slip in his controversial bit, and then it's an outrageous attempt to give himself some sort of credibility by going on about very simple things in obscure language.
Continue. Shall we continue?
Yeah.
Simple that you could put it on a T-shirt and get people to do that process of the finishing the argument off for themselves. So this argument states, if all horizontal planes are parallel to the plane of the horizon, then all horizontal planes are parallel to one another.
Perfectly sound as long as there's only one plane of the horizon.
Correct. No, as long as you know how to define the plane of the horizon. The totality, I don't know how you measure things to be parallel to it.
I don't either.
But the horizon isn't a plane, actually, most of the time. Unless you're actually looking straight ahead, it isn't actually a plane. It's slightly curved.
That's right.
So it's complete. So, again, we've invalidated
No,
the fundamental
it wasn't. You see, you're assuming things, and I'm asking things. I ask him, is the horizon a line? No. So where is the plane? The plane is, according to Bev, you're looking at the horizon, doing 360 degrees is the totality, which is the plane of the horizon. I think I described it accurately.
The horizon does actually form a line. If you actually were to
Are you
align
arguing with me or with Bev?
I didn't understand your point, I'm afraid.
The point is that Bev says there is no line. It's the apparent position where the sky meets the water.
He says there's no line.
Yes. He insists, even though I had on my screen a quote of his that the true horizon, the sea horizon, is indeed a straight line.
But hold on, I'm confused now. You're saying he said it's a straight line, and then you're saying he said there isn't a line.
Yeah, well, that's not new that Bev changes his mind, probably.
But
more
I've
than
always
changes
okay. I always thought he thought it was a straight line because he keeps on going on about how horizontal is a.
Depends. It depends what suits him at that
Okay,
moment.
I haven't heard him claim that it's not a line.
Yeah, let's keep going, guys.
That seems a rather odd claim.
Now, that's the simple argument. That's the argument laid out with the way for you to check it. I mean, obviously, you can check that for yourself by looking to see if you can find a horizontal that isn't parallel to the plane of the horizon.
We can do that.
All known horizontals have been, will be, parallel to the plane of the horizon. So much so that the word horizontal obviously comes from the horizon. There's a similar relationship there. So obviously all horizontals are parallel to the plane of the horizon, and you just check it out for definitions if you want for yourself. I could.
What did he say?
Could go over some of these definitions. Get some. We get some definitions of horizontal, right? Anybody can do it for yourself. Check up horizontal, and you will find the definition. Here's one. At right angles to vertical, parallel to level ground, parallel to the horizon, horizontal position. Don't worry about that one. It's a bit too triggering. That a horizontal position. I'll get some more. If anybody wants to have any definitions of horizontal, this is from a mathematics website. Any horizon over ocean is horizontal.
Now that must be a
loads of
line.
ways to do this for horizontal. So
Yes.
No,
I
it's
don't
not
think
the
it
plane,
really
it's the
needs me to
horizon.
go over too many more.
I actually have a pretty easy way to disprove this.
This one is one. There's another one. I'll give you another one. Horizontal, parallel to the plane of the horizon.
Can you pause this for a moment, Blue?
Yeah.
Yeah. Well, you're a pilot, and I don't use a bubble sextant that much because it doesn't work on the ship. But as pilots, actually use bubble sextants more. If you take two bubble sextants at least 69 miles apart from each other and measure at night the same star, they measure a different angle. And that will actually show that horizontals are not parallel.
That's a very good point. Yeah.
Yes, I don't know if Bev he avoids the subject of stars. I don't know whether he would claim that stars are local, in which case you can argue that if the stars are local, then you can actually have that. But if you say that stars are very far away, then Captain's correct that if your angle to that is changing, then obviously your angle or horizontal has changed with respect to the star. Therefore, your horizontal has changed if you accept the star is a long way away and of the same angle.
Correct. And we went over this in the Eratosthenes argument, and he denied. Eratosthenes assumes that light rays from the sun are parallel, which they approximately are. But of course, Bev says no, that's wrong. And paper said, yes, but that is consistent. That change in angle is consistent with the stars being or the sun being very, very close.
Yes, and I'm not sure that Bev actually agrees. I don't think Bev thinks that he just doesn't understand the geometry of it. I don't think he just says I'm just going to say no. I don't think they're parallel, but he doesn't then go to the conclusion. Therefore, you must have a near the stars must be close. Because he doesn't understand geometry. He doesn't understand the implications of the. If you're saying it's not parallel, then you have to say that the stars are close. If you then move and they
well, he said, or rather, paper said it for him. And I think Bev said it himself. They're much closer than than astronomers.
Did he say
think.
that?
So, yes, I've got a link to the video, and I'll have another look. If
Yes,
I can
because I'm
bear
not
the
sure
pain
that
of watching it again.
Yes, I know it's so awful. I mean, I saw that. Obviously, I saw you doing that, and but I don't recall.
Yeah, you helped with one of the diagrams. Do you
I did.
remember?
Yes, I did. I saw the video. Yes, I'm saying I did. But I can't remember him saying that stars
You may
were
be
close.
right.
I think paper did.
Paper did, but then Bev agreed with him, which is assent, isn't it? So
Yes, it's an indication.
Also, I know Bob the science guy, this is going way back, talked about bubble sextants, but flat earthers will always avoid bubble sextants. Always.
Well, of course, Bev doesn't accept sextant's work. He does not believe.
No.
His classic phrase is, "You can't get anything from an angle," which I mean, it's just incredible. Even though Tiny Captain here, does quite a lot with an angle that he gets from sextant readings.
So it's Tiny
It's my
Captain,
hobby.
is
I
Tiny
own a good
Captain-
one.
Is Tiny Captain
Well, when-
on that page? Sorry, I don't know.
He's a captain. He's a
in
boat
my
captain.
I'm
in my
actually
execution
a
of
merchant captain, yeah.
In my execution of the Eratosthenes, I used neither a bubble sextant nor sticks. I used theodolites, which is essentially, a bubble sextant on steroids.
Yeah.
Yes.
But for some reason, you can't use optical measurements. Oh, but then it was supposed to be the year of the sextant, wasn't it?
Indeed, and of course we're dealing with Bev here, who doesn't believe an auto level shows you what's horizontal. If the thing's more than 100 meters away, he doesn't believe the object you're looking. The auto level is telling you it's horizontal. If you've got a star going, if you could see a star through an auto level, because the magnification means you probably couldn't. But if you could, or the moon, if you could see the moon, he doesn't understand that. What? Who's Tiny? You're doing some DIY or something. He doesn't. He doesn't.
You can easily point that auto level. You can easily point that auto level at the setting sun and clock the time it crosses the crosshairs, and you'll see in the ephemeris how many degrees up it is.
Right, and the moon, if you so for instance, the moon can be horizontal to you. An auto level, if you look at the moon through auto level, you can determine when it becomes horizontal to you. But Bev doesn't
Just
accept
like
that.
the sun.
Yeah,
just like the sun. Yeah.
Well, I was just trying to avoid looking through anything at the sun. That was all.
Yes, don't look at
Optically.
things through the sun. Sorry,
At
through
the sun,
a
through an
lens.
optical device. Yes, that's why I was picking on the moon to be safer.
Yeah, moon is much safer.
But my point is that Bev does not believe that the moon, when the graticule passes through the moon, that means the moon is horizontal. He does not believe that an auto level gives you what's horizontal. He believes that because
he does believe it works at short distances, correct? But
yes,
suddenly, beyond 200 meters, it suddenly starts sort of.
Yes, suddenly stops working. Yes,
is that it?
Indeed, that's right. Because what he's read, because he's never read a surveying book, we know this because he hasn't got one. He said this. Even though he's got a certificate, I think the only thing he got a certificate for was standing in the rain holding a measuring rod. That's all he ever got that for. But he doesn't understand that because of this range business, they talk about auto levels, and that's because that's the range with which you can read a measuring rod. And as Blue found when discussing with him Blackpool Tower, he seems to think you've got to have a measuring rod in the picture. If you take the measuring rod out of the picture, the auto level ceases to work, or anything beyond the distance to a measuring rod, which you can determine the numbers on it. Somehow the optics goes wrong. I mean, it's just an extraordinary position.
Yeah, let's.
Yeah, it goes back to what in reading the instructions you get in your Home Depot level. It says, yeah, like at 200 feet, you kind of call it off and pick up the gun and move it. But that doesn't mean that the gun it can only work at 200 feet. That's an instruction. That's a method. That's a procedure. That's not really an instrument limitation. So, for instance, when I take my manually indexed level and I'm sitting on the Cove Mountain Ridge and I get it all leveled up and I'm looking clear over the top of these radio towers and I take my best 0.2 arc second theodolite, level it up, and I'm still looking above the radio towers. Now, the thing is, with my theodolite, I can measure the angle down. With my auto level or my manual level, I cannot measure the angle down.
You can't do
but
that.
I still see that those crosshairs are looking into blue sky to a radio tower, which is 1,000 feet higher.
Does the theodolite have some kind of gravity measure that tells it which way is up?
Some do.
Absolutely. Absolutely. It has a modern total station has the same compensator device as the auto level.
And I've got to say,
an older theodolite has a spirit vial, much like a carpenter's vial, except about 5 magnitudes more sensitive.
I don't know if people remember this, but about a year or two ago, when George was having an argument with Bev, and me as well, particularly with George, when I remember it, Bev does not believe that theodolites have the equivalent of a compensator or a pendulum inside them. He was astonished to discover that theodolites could determine horizontal from an internal compensator. He didn't. In fact, I think he still denies this to this day. He seems to be, because he's had an auto level, got an auto level. He thinks those are the only things that can determine horizontal. He does not believe theodolites have a pendulum inside them, in effect, a compensator. He doesn't accept that.
Which is what a theodolite is for, correct?
Yes, I know, it's extraordinary.
Exactly. That's how they surveyed all of Great Britain in the 18th century with a bloody great big theodolite.
Well, but correction, in the 18th century, they had 2 separate instruments. One was a vertically oriented theodolite, essentially the same as a horizontal theodolite, but the circle was separate. But they were 2 different instruments due to the scale of the manufacturing and such. Until about 1920 or 1910, did you have the combined horizontal vertical circles in a single
I shall-
instrument.
If you don't mind, I shall check that, because my understanding is what they called the Great Theodolite, which was used to survey India, was actually combined the two functions. But I will check that.
Yes, I was
Well,
about to
yeah,
the
but
other
in the geodetic surveys run by Ordnance Survey and National Geodetic, or the U.S. Coast and Geodetic Survey in the 1880s, 1890s.
See if I still got audio. I don't know. Yeah, I think I'm still going out. Hey, shout out to Tommy Grunwald for 50 NOK. He says, instead of reading the definition of horizontal, why not just get the definition of horizon? Isn't that what it's all about? Good comment. Thanks, man.
When they made more portable
Am I-
instruments.
So am I correct? The Great Theodolite, the Ramsden Theodolite, which is now destroyed, could combine the two functions, correct?
Yes, they could be combined. There was no, mechanical reason you couldn't. There was a practicality reason that in the precision surveys, they did generally use two separate dedicated instruments, the horizontal instrument and the vertical instrument, because they would be observing at different times of day and different crews. I mean, it was a very different operation in measuring the zenith angles, because they would do that, for a week, and they would do the horizontal angles maybe for a couple of days.
But the key point is that Bev does not accept that theodolites have effectively a pendulum inside them, and he had a huge argument with me and George about this over a year ago, 2 years ago. He does not believe this. He was astonished, and he just doesn't accept it. I think even now he doesn't accept that. That's what theodolites can do.
Quite simply, if you take your total station and put it in the vertical angle readout and dial it to 90, you are just as level as an auto level, assuming it's been adjusted.
Yep.
Let's see if we can
does
get
not
back to
believe
this video.
theodolites can give you horizontal.
Because nothing in this video has a damn thing to do with theodolites. So let's see if we can get back to what we're working on here.
Or relating to the horizon. In mathematics, this one. Mathematics, measured or contained in a plane parallel to that of the horizon, horizontal. So it's pretty clear that horizontals are parallel to the plane of the horizon. And as the logical form says, if two straight lines, i.e. two horizontals, are parallel to the plane of the horizon, then those horizontals will be parallel to each other.
No, that's a big mistake.
Simple argument. Simple statement.
Well, two lines can cross each other.
So
and
those
still
will
parallel.
be the two arguments that I will be bringing today up for discussion. I'm willing to discuss that. Obviously, those are just the basic arguments that we can put forward. There are plenty of geometric backings to prove these, the perpendicularity relationship, the shared straight line segments of straight lines, the existence of horizontal planes in reality, because they're established by tools called levels.
Yeah, which don't use the horizon. They are but just in case people don't know, in surveying books there is no mention of
How
the
long is that?
horizon for determining horizontal. Horizontal is determined by an auto level or some similar, or theodolite or whatever. There is no mention of horizon in surveying books. It's not used. How would you determine horizontal based upon his principles, the horizon, if you can't see it or whatever?
Shout
We've
out.
got auto levels that can show you horizontals.
Shout
Completely
out.
ridiculous.
Shout out to Windbreaker for 50 NOK. Says, here's another 50 Nokia dollars. Thanks, man.
And I have to say goodbye now. So good night, gentlemen.
Bye, baby.
Good night, baby.
later.
Wish we would have gotten further.
Goodbye.
I mean, it's amazing for someone like Bev, again, who's got an auto level, he doesn't understand how horizontal is defined by surveyors. I mean, it's just, and the etymology might indeed, the etymology of horizontal may come from horizon. So what? There's lots of examples where the etymology of a word has no bearing on its meaning. In fact, can mean the opposite of what the etymology suggests.
In short, nobody uses the horizon as a point of reference with the exception of a marine sextant in a marine environment. Everybody uses zenith and perpendicular to zenith because even your little carpenter's level is sensing zenith.
And of course, it's not horizontal.
Well, I don't use the section to make it horizontal. I use the direction of the actually horizon, not a point, a direction, and a direction of a star to measure an angle, and from there I calculate the angle. And
in a marine environment, the marine sextant, you're confronted with using the horizon, but in no other application does anybody use the horizon as a point of reference. It's perpendicular to zenith.
And it doesn't give you horizontal to you either. That's the point. The horizon does not give you horizontal.
Not. Absolutely not.
I shall end my argument there, or those two arguments. Leave them.
The angle from straight down to
leave them up for discussion.
Yeah, sorry, I was muted. You continue as long as you want to. I don't care.
No, that's I think for the laying out of the arguments, that's about as much time as I need, I think. Okay, so laying out two arguments, explaining the arguments and presenting the arguments without shouting at anyone, just laying out some simple arguments. Now, remember, Blue Marble asked for the debate to be level is ... question mark, and all horizontals are ... That was Blue's request for this debate. And after interrupting me,
I'll stop whining.
do you want to see Blue's all horizontals are and level is? Let's see where he goes. There we go then.
Okay.
Address the
Well,
we'll talk about it later. Yeah. Yeah,
let me see if I can rearrange all my stuff over here. Hang on. I think I can opt out of that and go back to this. And let's see, are you guys still seeing my screen over there in your Discord?
Let me get that.
I'm seeing it.
Yep.
Okay.
Yes, I can see it.
Well, if that's it, I'll just play this video and we'll continue after it's finished. Is that okay?
Look, have you seen the title of his video? Right, he asked me to do a debate about level is ... and all horizontals are ... and look at this opening thing of his video. That he's prepared a video for a debate. He must be nervous. I think. I want to do it live. But look at it. Just presented two arguments for him. He's yet to provide proof. All right. If anybody needs to stop or anything of this, because you might need me to go over Blue's argument within this video. It's about 12 minutes long.
I can stop here because you already provided proof, because syllogism is a proof. So,
well,
so
not if you have a globe belief.
He's pre-prepared his video. He perhaps didn't know that that's what I was going to be doing. So he might apologize for it, and probably not. I mean,
apologize for what?
Have you ever gotten an apology for anything from any
being a Boy Scout?
Let's
wronged you.
Let's give him the benefit of the doubt that he's pre-prepared a video and he wasn't aware that I might be providing proof just moments before him doing this.
No, in fact, you've never provided any proof, not any proof whatsoever to this day, Bev. All you're good for is giving us dictionary definitions. No proof, just definitions.
I mean, he might have wanted to present it first. I don't know. Looks like Right the Hand's back. Welcome back, Right the Hand. You've not changed a bit. Okay, here we go.
Wait,
That's
what?
fine for me.
All right.
I'll go on
let's
mute.
see.
You say about 17 minutes.
It is 17 minutes and 30 seconds, according to the 1726 or something like that. Okay, here we go.
Okay. Here we go.
Well, hello, everybody. Bev Try Thinking says all horizontals are parallel to the plane of the horizon, and he also says level is horizontal, but he has yet to provide any proof of any of that. I say, on the other hand, that all horizontals are not parallel to the plane of the horizon, and I say that level is definitely not horizontal, and I can prove it.
You can prove it? I mean, I don't know why this is such a big thing. I mean, why Betty's still doing it. It's like actual proof. It's coming in a video. Who's had it for ages?
That's what we're about to do.
Here we go. Let's go.
Now, Bev Try Thinking's logic is this. He says, if all horizontals are parallel to the plane of the horizon, P, then all horizontals are parallel to each other, Q. All horizontals are parallel to the plane of the horizon, therefore all horizontals are parallel to each other. Both valid and sound, observable and verifiable. Well, I don't think so. That's a begging the question fallacy, Bev. The premises assume the conclusion to be true. You are assuming that there is one and only one plane of the horizon, ignoring any other possibility.
What's everyone think about that? It's like, is that a valid rebuttal?
Nope.
No, because this is not begging the question.
Of course it's begging the question. It's absolutely textbook example of begging the question, fellas. I don't understand how these guys think.
Because begging the question would be, no, it is not begging the question because you are using the plane of the horizon,
Wants two planes though, paper.
I see. When I did this, I specifically put all in there, as in to say every single one of them, right? To make it as easy as possible to refute, right? You just need one black swan. Oh, it's like Betty did the other day, right?
Yep.
He said all verticals are not parallel. So in order to refute it, all you need to do is show two horizontals that aren't parallel. I mean,
Yes,
that's it.
but
Dead easy,
this-
right?
Quick shout out to Mark Beiser for $6.66. He says, I switched my membership and Super Chest to pay for my NASA card. So you are officially a paid NASA shill. Hail Sagan. Thanks, Mark. I appreciate it.
Yes,
but then one of them wouldn't be horizontal.
Hang on a second.
No, I'm referring just only to what Blue is saying.
Yeah.
He is saying that Bev was begging the question. And it
because
is
Bev
not
was.
begging the question. What you can argue if this plane of horizon should be in plural or not, whatever. But within the argument, there is no begging the question.
That I think that's true, paper, but even more plainly than getting into the question of whether or not there's a begging the question fallacy is the misrepresentation of Blue saying that Bev is assuming one and only one plane of the horizon. Bev says right above there, he's got Bev quoted. Bev says all horizontals plural means that Bev's argument is talking about more than one horizontal plane. In fact, he's talking about all of them.
Can you not read
Is
what the
he a
guy?
retard?
Yeah, what's wrong with that guy? Can he not read what's written? Bev is saying every horizontal, no matter where it is parallel to the plane of the horizon. That's one plane of the horizon, not multiple planes of the horizon. He is assuming the plane of the horizon is a constant everywhere. Same plane of the horizon in South Africa as it is in New York City or Sydney. Sorry. That's your assumption, and that's what's wrong.
Hang on,
Implying more than one.
I want to disagree though, because I think he's trying to say that there's more than one horizon plane. Play it again.
Yeah, I know. He's still saying it, right? But that's not
more
what
than
the
one
argument
horizon.
is.
Not
right?
what
the
the argument says.
states.
But that's what he's trying to turn it into.
I know, but that's what we have to point out. The argument states if all horizontals are parallel to the plane of the horizon, right? It's having every horizontal having a relationship with the plane of the horizon. Right? It's not saying that there's only one plane of the horizon. It's stating that all horizontals have a similar relationship to it.
That's begging the question,
tell
buddy.
me you don't know what the plane of the horizon is. That goes to blue as well. I mean, every time you say the plane of the...
I don't think Bev knows the meaning of the word the, T-H-E.
Yeah, apparently not. He is plainly treating it as if there is one and only one plane of the horizon.
I'm not saying that there is only one, but the plane of the horizon.
Yeah. The plane of the horizon. How many is that?
Let's count.
Shout out to Stephen Mudd for 100 of those Nokia dollars. Why bother giving evidence for verticals and horizontals not being parallel on Earth? Bev will deny any of them anyway. And you're right, Stephen. Absolutely. Listen.
The
more
horizon.
than one of those.
Yeah, but every time you say the plane of the horizon, are you saying that there's only one? Or is it like a unique signifier of something that you know exactly what it is?
Right, I get you.
I mean, like, what you could do is you could look at the plane of the horizon in front of you and turn round and look at the plane of the horizon behind you. Are you saying that's the same plane of the horizon? Or is it two different views? Are you looking at different things?
No, that's what you're
while
saying,
still
Bev.
understanding what the plane of the horizon is. I think it's a weaselly way of blue trying to avoid the conversation, right? It's obvious ECV for me. Any way to avoid the actual argument.
The question I have here, Bev, is do we think that he got this from Betty?
No, that's both valid and sound, observable and verifiable was wrote by DP. So he's picked this up from a meme somewhere.
Okay.
I didn't even bother. I don't bother with that valid and sound and all of that. It means nothing.
It definitely means nothing. We saw that a little bit today, as a matter of fact. Yeah. I would say just by virtue of he may have been talking with Betty about this, and Betty may have helped him craft this because of the faulty logic that Blue is using in the yellow there. Just the idea. I mean, Paper's right. It's technically not a begging the question fallacy, but the idea that you would try to utilize a quote that clearly states horizontals as plural, and then claiming that your opponent is stating that they assume one and only one plane of the horizon sounds like Betty to me.
Sorry, bud, that was all me. Betty had nothing to do with it, just me.
Well,
I could be
Betty
wrong.
went with the cross on it, didn't he? Like that. Betty chose a different way to refute this, so don't think it is coming from Betty. They would have solidified their argument together, wouldn't
Yeah.
it? But Blue's going for something different. He's just saying it is. But like what he does is he puts in inverted commas, plane of the horizon. Well, no, it's called the plane of the horizon, right?
Correct.
Everybody, that's what everybody calls it. So why miss the plane of the horizon?
The fundamental
By-
problem
by
here
the
is
way-
he thinks the horizon is a 360 thing. So he thinks all horizons are made up of if you were to turn your head around 360 degrees, that's multiple horizons and they're all in the same plane. It's not quite true actually, but forget that moment. He's not considering that if you move your location, that the horizon is different on of a different plane.
That's
So
right.
he unfortunately so when he hears you talking about multiple not being in the same plane and multiple horizons, he thinks you're talking about just rotating your head. He's not considering, and this is a number of people haven't hammered this home when they've engaged with him. We're talking about when you move your location. I know you just mentioned it just now with your South African. It has been mentioned to him, but quite often I see debates in which this point is not thrust down his throat. That we're talking about a change of location, just the fact you've got a rotation, you're rotating your head and the plane. It actually only remains the same if you're looking horizontally, in fact, because if you do the perspective calculations, you get a curve, as we know that if you're up more than just a few tens of feet or hundreds of feet, the horizon is actually curved. But if you're looking horizontally, just the way the perspective calculation works, you would actually end up with a straight line. It wouldn't be in the horizontal to you, but it would at least be parallel. And of course, one thing actually also when he talks about this, the horizon is horizontal is parallel to the plane of the horizon. He never actually mentions where horizontal actually is. So he hasn't got a means, using his definition, of actually giving you horizontal. All he tells you is that the horizon is parallel to this horizontal to your position. Anyway, that's a couple of points there.
Yeah. Let's see if he ever lets me talk again. Maybe.
This is begging the question, and you should imply more.
I actually
than
don't think
one
I've ever seen a
plane.
better example of a begging the question
So
fallacy.
it should be
No, I would agree with that. It's textbook. Absolute textbook.
planes of
And I'd also say it's not valid either because he hasn't demonstrated that his premises are true.
Yeah, well, even his turning around.
You mean sound?
Even his turning around example is wrong. I mean, just fundamentally flawed. Even if the Earth were flat, if you're standing up above it, looking out at the horizon, and you turn in a circle, you're not seeing a plane. You're seeing the side of a cone.
Yeah, you're right on the Sanders. When I mean valid, it's the fact that his premises do not mean that the conclusion can, it's impossible for the conclusion to be false. But it's not sound either.
Yes, so you're saying it's invalid and unsound.
Yeah.
Yep.
Yeah.
Yeah.
I agree with that.
horizons, but we cannot see horizons.
Yeah, that
We
wouldn't be.
can see one horizon. So from one horizon, you can make only one plane from that line, this true horizon or whatever you can call it at the sea. You can see one line of the horizon, and this is horizon, this line where water meets the sky, etc. This is a line. So one line. So from that one line, which is horizon, you are creating the plane, not planes. Why planes? Other plane would be, might be parallel, but that would be not plane of the horizon, because that plane would be parallel to horizon, plane of the horizon. So that would be horizontal plane, but not of the horizon.
Yeah,
So,
it was made as a simple argument. I mean, I think everyone can follow along with it, and it's pretty obvious that, you know, like Betty struggled to what a square was and a plane.
Yes, my point is that I am rebuting his begging the question fallacy accusation, because from one horizon you can make one plane. So, so the statement that are parallel to the plane of the horizon is correct.
Paper, the fallacy is you're assuming that the plane of the horizon at Southport is parallel with the plane of the horizon in New York City. That's the fallacy.
Yeah. And if you would put there planes of the horizons, that would be incorrect. That would be incorrect. Blue Marble Science would say then that, okay, I am okay, because now it is not begging the question, because Bev is assuming more than one plane. But to assume more than one plane, you have to assume more than one horizon, and it is impossible because we can see only one horizon.
No, what you have to do is show that every plane of the horizon is parallel with every other plane of the horizon. That's
in
what you've
different
got to do.
locations.
In different locations, you've got to be able to show that the plane of the horizon does not change orientation as you move from one position to another position. You have assumed it doesn't, and that is incorrect. That is a fallacy.
And there's
Sorry.
another point. He said
it-
that
it
there's
cannot
more
be begging.
horizons. Well, every point you stand on Earth, you have a different horizon.
That's right. That's right. And their assumption is that every one of those would be parallel with each other.
And that's ridiculous.
And that is ridiculous.
And it's an assumption.
Yeah, it's an assumption. Yeah, and that's the reason it's a begging the question fallacy.
Yeah.
It assumes the outcome.
Yeah.
The question. I'm done.
Betty's come in. Well done. Good to have you here. Betty, I would say logic is the science of reasoning. Not valid argument. Come on. The science of reasoning. Betty.
By the way, did you mention
Using
earlier he said he
mind.
wasn't interested in this valid and sound business, and this is a guy who lectures people about logic.
Yeah.
He doesn't know the difference.
Oh my God.
Just incredible.
Valid argument. Yeah, it's not a begging the question fallacy, because
I think you would
he's
say that you
forgetting
just
there
ad
is
hominem.
backing from Euclid, right? So begging the question would be to assume your I don't know, but I'll leave that one to Blue and Betty. They seem good at explaining what it is. Begging the question. It sounds good though, right? I mean, a lot of people would probably be, well, that sounds good. Yeah, Blue, obviously it's a begging the question. It's not. It's a pretty good argument. Should try rebutting it at some point. We go.
Now, this is Bev's contention. If there were one and only one plane of the horizon, Bev might be right. But what he's asking you to believe is that a line, a horizontal...
He's done it again. He said, if there were one and only one plane of the horizon. No, it's called the plane of the horizon. Blue. Just changed it again.
line parallel with the plane of the horizon in Miami, Florida, also has to be parallel to the plane of the horizon in Jacksonville, Florida, or in Boston. This is pure speculation. No testing or proof whatsoever, just a simple statement. The other possibility is if the Earth is an oblate sphere, then multiple planes of the horizon have to exist. Gravity vectors, so that's verticals or zeniths, can't be parallel, and horizontals, which are
Sorry,
perpendicular.
can you stop here?
Yeah.
Because what he's doing now,
Yeah.
he said
preaching a
that
sermon.
you should make another horizon in different location, and you would see that they are not parallel, these planes of the horizon. This is what he's saying. And assuming that they are parallel, in his example, that would be just a speculation. So he is making speculation for you, and he's refuting this speculation. And he is suggesting that he's refuting your argument. No, he is refuting his own argument.
Paper seems to be grasping at straws here.
Which he called speculation. And now he is refuting
Yes, he doesn't seem
his
to
own
understand what an
speculation.
assumption is. He doesn't seem to understand there's an assumption in there.
Yeah, they don't seem to understand their own argument.
Yeah, I mean, if you say all horizons are parallel, you are assuming, without providing any logic for this, you are asserting that all possible horizons are parallel. So when Paper there was saying that he's refuting, no, you're just saying, well, hold on, you've got to provide a reasoning, an argument for this, and I'm saying, and you're just pointing out that he hasn't. And until you have provided an argument for this that's valid and sound, you can't assert it as being true. And he doesn't understand that simple piece of logic, because Paper's logic is almost as bad as Bev's.
Yep. At times, even worse than Bev's.
Yes, in times, sometimes, yes. I mean, they sort of alternate, I suppose, yeah. It can be worse, can be better, yeah. I think, yes, it's difficult to say which one's the worst. Yeah. But it's amazing that they don't see that, given the fact they talk about logic, they talk about the trivium, they talk about Euclid, they talk about logic all the time, and they can't see that the word all there needs to be justified. All horizons are parallel. Well, you can't just assert this. This is the thing we're trying to determine.
Right. I've given you two valid possibilities. If all horizontals are parallel everywhere, then what I said to begin with is true. The plane of the horizon in Miami is the same as it is in Jacksonville, Florida, or New York City. On the other hand,
he doesn't seem to want to consider that possibility.
On the other hand, that's one possibility. That's the one he goes with. The other possibility is this one that's on the screen right now. What if the Earth is not flat? What if the Earth is an oblate spheroid? In that case, horizontals are not parallel.
I mean, it's just amazing that he doesn't understand that he's making an assumption. It's simple. All you're saying, and all you pointed out was, yes, that you're saying that the horizon in Miami is the same as parallel with the horizon in Boston. And you're pointing out that is an assumption that he has made, and he doesn't recognise that that's an assumption he's made. It's just extraordinary.
Yeah. Let's keep going.
Yep. So this is what he is doing now, for people to know what he is doing in debate.
The other possibility, he's called it.
Yeah, but this is his invention. This is his speculation, not yours.
Yeah, he's not actually bringing his own argument, or maybe this is. It seems like a rebuttal to my argument as well, really. But
yes, but he is creating his own speculation, and he is rebuting this speculation as your argument.
It's a straw man, right? He's
kinda, yes.
Making a semi-straw man. I mean, half-arsed. But he's led by, obviously, the model's dictating to him what he has to do. It's a valiant defense, right? But predictable.
To those verticals also cannot be parallel. So can we test this? Well, absolutely. We need two things. We need two fixed points like a point there and a point there. And we need a
That's 2 points.
way to measure angles A and B. And we'd like to do that simultaneously if possible. So how does that help us?
You can see this shape he's making here. It's familiar, doesn't it? We've been going over this. It's great.
Yep.
Well,
I'm not
let's go
watching, but
to
is it
you.
a Donegon?
No, it's proposition 5.
Oh, parallel postulate.
No, it's
Okay.
the fifth postulate. No.
I'm watching now.
It's isosceles triangles.
Euclid and Euclid's Elements, Book 1,
Similar
Proposition 29, which says a straight line falling on parallel straight lines makes the alternate angles equal to one another, the exterior angle equal to the interior and opposite angle, and the sum of the interior angles on the same side equal to 2 right angles. And further down we see Euclid say this: therefore the sum of the angles BGH, that's that one, and GHD, that's that one, also equals 2 right angles. BGH plus GHD equals 180 degrees. And this is how we can find out whether or not the verticals are parallel. That's all I'm pointing out using Proposition 29. That would be a perfectly valid test to find out if the two verticals are parallel with each other.
You will note here, please, I hope everybody's noting, Blue Marble Science is using Euclid, Proposition 29. It's quite a good one for him to use, this one. But it is definitely Euclid, and he's talking about 100.
Well, yeah, Bev, we know it's Euclid because it says fucking Euclid up at the top of the page.
180 degrees being here. Much like in Euclid, triangles have the sum of 2 right angles also, and a straight line. No more.
Can I ask?
Go on.
Can I ask something? Well, I'm just thinking this is still early in Euclid, so this is all 2-dimensional geometry that we're dealing with.
Absolutely. This is the first time, around about the first time the parallel parts get mentioned.
Well, I'm just wondering how he applies all this 2D geometry to the Earth, which is 3D.
He's about to do it now. He's about to show you.
Yeah.
Yeah.
Yeah, that's what I'm waiting for.
Well,
All right,
we
let's
call
go.
this the stolen concept. Or really, it's a self-refuting claim. But he doesn't understand that just yet.
No, I'm sorry, Bev. You're the one that doesn't understand what stolen concept is, and that's not what this is. This is not stolen concept.
I'm not so sure whether people will, but hopefully you can catch up at some point.
But what happens if lines AB and CD are not parallel with each other? What happens if they look like that? What happens if they are converging? Well, in that case, BGH and GHD have to be less than 180 degrees. That's easily provable. On the other hand, what happens if they look like that? What happens if they are diverging? Well, in that case, BGH and GHD have to be greater than 180 degrees. So the measurement process, we can test this with 2 theodolites. Those are instruments that precisely measure vertical and horizontal angles. We can put a theodolite at each of 2
There's
positions.
the 3D switch.
And measure.
No, this is he's doing the reciprocal theodolites, but I mean we're gonna do auto levels. This is how we do the rumpus pole simultaneous below. We've got them covered. Sort of the inspiration for it.
Measure the vertical angle to the other theodolite. We'll put a theodolite there, and we'll put another one over there. We'll point those 2 theodolites at each other, and we will measure angles A and B. Now there's.
See, you always know when you're dealing with blue marble geodetic surveyors, right? Because what they do is they like to point tools at each other. They like to get the tools out and point them at each other. You can always tell that this doesn't happen with like what we call it, normal surveyors, like normal geodetic surveyors, or maybe plain surveyors, or the local surveyors that you see around the place, right? That just survey locally. Now these are special blue marble armchair. Well, I mean these ones aren't, because they're actually out there pointing.
Yeah, geodetic surveyors do this all the time. They measure zenith angles. They measure reciprocal zeniths. We've got books and books and books full of those measurements. I don't know how you continue to deny this when clearly you don't even know how a theodolite works. All you can talk about is an auto level.
Pointing theodolites at each other. But you can always tell, obviously. Blue marble surveying techniques. Pointing tools at each other.
There's our little sketch from Euclid. Let's turn him so it looks a little more like our verticals here. And you can see that if the verticals are parallel, angle A plus angle B has to be equal to 180 degrees. It has no choice. They don't even have to be at the same elevation. The theodolites could be at two different elevations. You just need to be able to point the two theodolites at each other. So if Bev is right and all horizontals are parallel to the plane of the horizon, meaning all horizontals are parallel to each other, then all verticals must also be parallel, and the sum of internal angles, in other words, reciprocal zenith angles, has to be exactly 180 degrees, as Euclid Book 1, Proposition 29 says. But what if
Euclid doesn't really say much about pointing theodolites at each other. In fact, I'm pretty sure he doesn't.
I'm pretty sure Euclid also doesn't say anything about horizontal or vertical, Bev. At least I don't know where to find it.
Did you just argue that?
No. No, I'm just making a point.
I know, but did he just say that Euclid didn't say anything about theodolites?
Yeah, that's what he said.
Wow.
And my
So
rebuttal to
couldn't
that
find-
is Euclid also doesn't say anything about vertical or horizontal.
Right.
He couldn't find a weaker argument.
As I say, can you find a weaker argument, Bev?
No, I think he pretty much got to the bottom of the barrel on that one.
Yes, and he's messing orthographic view with perspective. So
what?
Because this red line, that would be I don't know what it is.
It's just a line. It's just a theodolite looking at another theodolite.
Yes, but looking at me.
It's a line of sight, cardboard. Pay attention. It's two theodolites aimed at each other. It's just a line of sight, which is replacing Euclid's line in that little diagram. We don't actually need a line. We can just use a line of sight. That's what's done. That's how we do it.
Means that someone is looking and maybe it is or should be line of sight in his view, but it isn't.
Yes,
yeah,
it
they've got
is.
no rumpus pole to look at, so they have to look at theodolites, right?
Yes, but in perspective, theodolite is smaller than than this theodolite.
Look, nitwits, in terms of these zenith angle measurements, when you're talking about over distances of 10 or 20 or 50 or 100 miles, you're not really actually looking at the theodolite. You can't see the damn thing. What you look at is a signal mirror or some other bright source of light mounted where the theodolite is. That's what you actually take a sight to, not the theodolite itself. Jesus, you guys claim to know what you're doing and what you're talking about when it comes to surveying, and clearly you don't have a clue.
At which you are looking. So your theodolite in perspective is greater than this distant one.
Yeah, you're going to end up with the equipotential angle, right? Because
Yeah,
you're measuring
but
angles, so that's what they're after. Equipotential angle of adjustment. It's on the
Yes.
way, right? You can see the process, though, can't you?
yes, this process is made by ignoring perspective. So they have to ignore perspective.
It's not often performed. I don't think there's many people that have actually done this. There's a couple of shadow giants, right, that have
Maybe, yes.
actually been out in the field pointing theodolites at each other. I don't think they're around anymore.
Jesse Kozłowski
Yeah, he's
did
gone.
that, yes.
He's gone, sadly. And
What a terrible misrepresentation of the truth that is. Yes, Jesse and Larry, who's in the Discord with us right now, have made reciprocal zenith angle measurements, but they're not the only guys that ever did it. Larry, you still on the mic there? He might have stepped away, but we've shown you many other examples of it. The McDonald Observatory, for instance, there's 7 or 8 or 9 reciprocal zenith angle measurements in that thing. If you go to the Transcontinental Survey, that has got hundreds of them in it. These people just absolutely astound me at their willingness and ability to misrepresent the truth and to misrepresent factual history, things that anyone can go on the internet and get the report from 1900 for the Transcontinental Survey, or the report from, I think, the mid-70s for the McDonald Observatory, and you can look up the information yourself. It's absolutely astounding that these guys can sit there and lie like this and still pretend like that they're right. It's incredible.
And I think they're still surviving. I think Larry Scott, or Larry GPS, or I think he's more commonly known by the name of Shoebill. Now goes by the name of Shoebill. Shout out Shoebill. You might be needed to explain the noble art of looking at theodolites through theodolites. I mean, well, it's a well-known geodetic surveying thing. Well, blue marble surveying technique, made up by Jesse Kozłowski and Larry. So take the floor anytime you want. This is obviously blue marble's never looked at a theodolite through a theodolite, but he's going to now tell you exactly what the process is and how it works through blue marble geodetic surveying. So here we go. But blue marble's definitely an armchair blue marble science geodetic surveyor.
Horizontals are tangents to a spherical surface. Then horizontals can never be parallel, nor can verticals be parallel. The sum of the internal angles A and B will be greater than 180 degrees in every case, if the surface of still water or points of constant elevation form a curve. By golly, we got us the makings of a test.
Didn't I just went through the one with equal elevation as well before and said, you know, that it was the same as the horizontal, but he seems to have missed that. So he's going straight for the new science test. Let's do
Bev, let me introduce you to a couple of guys. One guy named Jesse Kozłowski and another guy named Larry Scott.
Unfortunately, Jesse Kozłowski has had to do a Jesse Kozłowski leave the arena.
Oh, Jesse's
Said some
around.
really
Bev.
stupid shit. He obviously can't back up, so he's just gone. I don't know whether he listens in every now and again. Maybe. I doubt it. Probably too painful for him. But Larry Scott, as we said, he's still in the arena. So shout out to Jesse Kozłowski. I know you're not around here anymore.
Doing a Jesse Kozłowski.
Yeah. And Larry Scott, Shoebill. Back in 2018, like quite a long time ago, they were looking at theodolites through theodolites. Quite a long way. So
Ridiculous.
here we go. Look, Hagerstown.
Want to talk about a long time ago? The Transcontinental Survey report was published in 1900, Bev, 123 years ago. That's quite a long time.
I think we were looking at this the other day.
2018, those two guys got together at the Hagerstown, Maryland airport and High Rock Lookout, about 11 miles apart, and measured reciprocal zenith angles. How about that?
Wow, how about
Larry
that?
was at the airport over there. That's Larry's theodolite and the signal mirror. And Jesse was up on top of High Rock Lookout. You can see where Jesse was located, where that red arrow is.
There's an arrow there.
Those two guys measured the two zenith angles. We'll call the one at the airport A and the one up on High Rock Lookout B.
Those look parallel, don't they? The heights for the elevations on that graph.
Yeah, idiot. That's the way we draw elevation profiles.
Would you?
Yes.
Okay.
So they were measuring allegedly from a straight line, horizontal.
From this, yeah. These look like the parallel. Don't know whether they are. Maybe. I think this is Google, and I think that's the way it does it. You know, it lays out an elevation profile to a straight line. So, I mean, that's what they were doing. They were out there measuring this angle and this angle. Well, actually, they were looking at each other. So they were pointing it up in the air and measuring an angle down to each other, right? So they were ending up looking at a theodolite.
What does he mean, pointing it up in the air? I have no idea what he's getting at. They set the theodolites up. They get them leveled up properly. In fact, Larry was using a Wild T3, I believe, and Jesse was using I don't remember what. He's using a more modern theodolite, but in both cases, the reference was zenith. When you level the thing up, that's what you're doing. You're setting it. You're setting its vertical axis up parallel to plumb at that point. Now all you do is read the angle off the vertical circle. That's how it's done, Bev. These are theodolites. These aren't your auto levels. These are theodolites. And they are specifically designed to measure vertical and horizontal angles to extremely high degrees of accuracy. And here are the actual measurements. Larry measured angle A to be 88 degrees, 57 minutes, 58.2 seconds. Jesse measured angle B to be 91 degrees, 9 minutes, 55 seconds.
So, each of them have an angle. And you know what we say about that? Well, you get two geodetic surveyors with an angle each. Well, magic can happen.
Just like Euclid, Bev. Exactly the same thing as Euclid. No different. That is a total of 180 degrees, 7 minutes, and 53.2 seconds. 180 degrees,
Can I ask
7
a question?
minutes,
Hang on,
and
Ben.
53.2 seconds. Those two verticals are tilting with respect to each other. You see that, Bev? They are not parallel. They are diverging. They are tilting if you reference one to the other.
Is that something?
Are seconds and minutes units of distance measurements?
No, they're angles.
What a genius.
It's an angle measurement.
Okay, I'm good.
It's a little bit over. It's a fart of an angle, right? You get a degree, and then you divide that degree into 60 components, and you call each one of those a minute. And then you get one of those minutes, and you divide that by 60, and you call them seconds.
Like in a clock. The same.
Minutes and seconds, 60s and 60s. So a second is a 3,600th of a degree. And a degree is a 360th of a circle, a unit circle. So yeah, he's added a little bit here. It's a little bit extra. Right?
Oh, wait a minute. I didn't add anything there. Those are the two zenith angle measurements, Bev. Nobody added anything. That's what was measured. Don't try to make it sound like somebody has monkeyed around with the numbers. Those are the actual zenith angle measurements, which when added together exceed 180 degrees. Just exactly like we were going through with Proposition 29. If the verticals were parallel, the sum of those two angles would have been 180, not 180 degrees in 7 minutes, 180 degrees, period.
I mean, these are two of the most qualified blue marble shadow giant geodetic surveyors, right? So obviously accuracy rating spot on, 100%. They never make a mistake, even over whatever distance. It could never be an angle measuring problem with them. That all they have to do is measure one angle each, right? And then they can combine them, like Blue Marble says here, right? So this is what you can do. You say you can do fuck all with an angle. Well, these shadow giants combine them. And
that is with no refraction correction. If you include refraction, that increases from 7 minutes, 53.2 seconds to about 9 minutes and 40 seconds.
Wow. So you add on a minute, so nearly 2 minutes for refraction with your angles. Obviously you don't, you just measure an angle. You don't add refraction on as an angle, an extra. Plus it's like lengthening your rumpus pole.
No, Bev. Refraction makes a distant object appear higher than it really is. And what that does is reduce those angles. When you take a refraction into account and put the 2 points back where they actually are, the angle increases a little bit. That's what refraction does. Obviously, you don't understand this.
I mean, like, you wouldn't do that, would you?
Yep.
He was telling us the other day, you can't lengthen a rumpus pole. You've got to shorten it. So making the angle bigger sounds a little bit silly. But hey, that's blue.
No, you just made yourself sound silly there, my friend.
It's blue.
Here's Larry's diagram with a little more detail on it. Again, there are the two angles that...
Larry's diagram. Has anyone ever seen this? Did you think it was an official technical thing? Or did you know it was just Larry's diagram? Some random dude posting some stuff. He's been on the top of a mountain, right, Larry? With a theodolite, looking at a theodolite, measuring an angle. Very clever. And he's done this. I mean, look at all the numbers on it and stuff.
Ooh, scary numbers.
He was here measuring an angle. I've got an angle here.
Those guys measured, and there is the sum of those two angles. 180 degrees, 7 minutes, 53.2 seconds.
I did 2 angles.
That's 7 minutes, 53.2 seconds in excess of 180 degrees.
2 angles.
Now, just in case you thought this was a one-off,
yeah,
this is a report done by NOAA back in 1978.
Just in case you thought that 2 old dudes, one of them is not around anymore, actually just measured 1 angle each and combined them. Well, no, look. Lou's got a book.
It's a survey of the McDonald Observatory radial line scheme. They were measuring reciprocal zenith angles from 7 different positions to a place called Baldy. Here are those measurements. In the interest of time, I'm not going to go through all of this data, but I will call your attention to a couple of columns here. That one and that one.
Look at this.
The first one is the sum of the zenith angles. The second column is plumb line tilt. That is simply the sum of the zenith angles minus 180 degrees.
He did just say plumb line tilt.
Plumb line tilt.
Yeah. As though it was not.
Yeah, they're tilting with respect to each other. What is it about this that you have such trouble understanding?
Nothing, right?
Tilting plumb lines.
Didn't even.
Yeah, I
think to
wish I could
question
get to the
himself.
freaking mute button faster. I wanted to say that. Like, who even thinks of plumb line tilt?
But it's got a column there. Like, this is, you know, like somebody's wrote it down.
Official government document.
Yeah.
Isn't that just saying that the difference between the vertical at one location, the vertical and the other?
Same plumb line tilt.
But that's what it is. He's saying the sum of the zenith he's saying the sum of the zenith angles is greater than 180 degrees. So that's saying that there's a difference in angle between the two plumb lines, and he's calling that plumb line tilt. But
I know.
It doesn't mean, So
we've got equipotential angle of adjustment, right? It's much better than plumb line tilt. I mean, plumb line tilt sounds fucking ridiculous.
Equipotential angle of adjustment. You don't think that sounds ridiculous, Bev? I do.
A rose by any other name would smell as sweet, right?
No.
Plumb line tilt.
No, this
sounds
smells like
fucking
shit,
stupid,
dude.
right? That's ridiculous.
But no,
This smells
the
like
same
total
thing.
dog shit.
It is the equipotential angle of adjustment. It's the same. It means the same thing. The calculations are giving you the same number.
But I mean,
He's just calling
it just
something
sounds ridiculous. You can't go round
Can
saying
you
to
tilt the plumb
people
line?
that you've got plumb line tilt. Like, it's got a column called plumb line tilt. I mean, it doesn't happen. It can't happen. It is an angle of adjustment, right? The equipotential angle is the angle measured between these two things. But I mean, it's not plumb line tilting. Plumb lines just don't tilt. It's fucking ridiculous.
You call it what you want. I think the important thing is that, like, they're measuring that these two plumb lines are not parallel.
Well, he's measuring an angle, right, and then calling it plumb line tilt. That's all that's going on at the minute.
No,
We've got two
no.
guys.
If those two plumb lines are parallel, the sum of the zenith angles would be 180. So what he's saying is that the two plumb lines are not parallel, and the difference between the two.
No. What he's saying is there's two guys that are measuring angles, and they're combining the angles and putting that number that they have that when they minus 180 from it in that column and calling it plumb line tilt. That's what's going on.
I know, but what the number is the difference in angle between those two plumb lines.
No, it's not. It's when you add the two angles
They're
together
plumb lines,
and
they're not.
minus 180, you
Yes,
get
because
that angle, right?
Yeah.
Okay.
If the plumb lines are parallel with each other, you would get an exact angle
It's
when you
just a
sum the zenith
measurement
angles
of an
of
angle.
180. If
With
they are
an
not
optical
parallel,
device, no. The optical devices don't work like that.
no, if you're measuring the sum of the zenith angles, not accounting for refraction for the moment, if the sum of the zenith angles is 180 degrees, then those two plumb lines are parallel. If it's more than 180 degrees, they're
Right,
different.
everybody understands that there's two guys measuring angles, one at A and one at B. They combine these two angles, minus 180, and get that angle. That everybody understands that's what's going on. Like, you don't need to come and tell us exactly what's going on again, right? We understand.
Two optical devices not meant to look at one another from a distance of 17 kilometers away or whatever it is, looking at each other from 17 kilometers away, getting an angle apiece, and then claiming that it's plumb line tilt. That's what we have
Just
here.
put it in a
Don't
column
try to
called
put
plumb line
lipstick
tilt.
on the pig, dude. That's what's happening. Embrace it.
Yeah.
We
We
what's
would never
happening,
call a plumb line tilted.
So you're just haggling over the name. That
Yes,
number.
yes.
What?
We are now going to carry on. Yes. It was just pointing out that he's got a column called plumb line tilt, and Blue Marble thought nothing of it. Right? He's breezed past it. You're here defending it. Right? I personally think it's fucking ridiculous.
You can think what you like. I
know.
understand
That's
what it
all
meant.
we were doing. We were just pointing out.
Good for you. Excellent. Carry on.
Mm-hmm.
I have one notion about this looking at theodolites through each other. Because Ramshutu said that let's ignore a refraction. But if you are looking through optical device, my question is why you are going to ignore perspective. You are not only ignoring refraction, but you are ignoring perspective.
Because perspective has absolutely nothing to do with it, Paper. You obviously do not understand what perspective means. You don't know why you are as wrong as you are. It's incredible. You really need to rethink that position. Perspective has nothing to do with this.
So that's why this looking through theodolites is invalid as a measurement.
It
And
doesn't. The perspective element doesn't matter. The only impact perspective will have in this.
Wait, whoa! You can't. You can't
Oh,
say
come
that.
on, let
because
him let
you
him
use
be the
optical
globe
device.
apologist. Come on.
Okay.
Let him go.
Okay, but the impact perspective will have at that is to amplify the margin of error in your calculations, because what you're trying to focus on is smaller. All of these measurements are angles. So as things get further away, the angle will drop to towards 90 degrees. But the sum of the zenith angles essentially removes the impact of perspective because you're summing it from both sides.
Okay,
So
brilliant.
what will
Thank you very
happen-
much. Can we carry on now? Right, we don't need a lesson because Blue Marble's doing that for us in this thing that we're going over. Or unless you think Blue Marble's going to make a mistake. And you don't want to preempt him, do you?
I think he's thinking Blue Marble's doing a shit job here.
I think
and
so.
He's got to
That's what
come
it
in.
sounds like.
Got to come in and explain it because it sounds fucking ridiculous.
Well, what's happening is you guys are doing a shit job of understanding it. I made it as simple as I could make it. What's wrong with you idiots?
So, yeah, we've got to explain it because plumb line tilt. Go talk to anybody about plumb line tilt, especially if they know what a plumb line is. Just go tell them. Yeah. Did you take into consideration the plumb line tilt?
And they tilt from what?
From each other, you nitwit. From each other. They're both plumb at their position. But when you compare one to the other, they are tilting away from each other. That's what it refers to. Any idiot can see that. Go ahead, Farmers.
Yeah, I think Bev understands this, but it goes against everything he espouses. So he has to sort of, make shit up basically, which he's very good at.
Yeah, the only thing he's got going
This
for
whole
him.
insistence. We're not saying the plumb line is at an angle, but two plumb lines a decent distance apart are diverging from each other. This isn't rocket science, for fuck's sake.
It's just a name. In fact, I didn't even do that page. Jesse Kozlowski did that, and he chose to call it plumb line tilt. There's nothing wrong with that terminology. If you want to use it, that's perfectly fine. He's simply saying the plumb lines are tilting with respect to each other. That's all. Nothing more than that. But these idiots don't have anything else that they can pick on, so they want to pick out a term like that, and you try to use that somehow as an argument. It's just stupid. You guys are just fucking stupid, Bev.
Yeah.
The
Yeah, and
equipotential
I just
angle of
wanted to
adjustment
say
just sounds
This
so
is the
much
problem. This is the
Go ahead, Chuck.
it's obvious that not every idiot can understand this. There are idiots that can't.
Well, you're going to have to be in pretty bad shape not to be able to figure this out. It really is not that hard.
the problem with academics versus people who do things in the real world.
Amen, brother.
Thank you very
what
much
he
for the
just said?
subs. Join in. Well,
Say what?
What it just said? People who actually doing things.
Yeah. Well, he didn't say what kind of things. But whatever.
well done. Is that Godzilla again? Thank you for Gods. For everyone that just got a membership from you. Okay.
Thanks, Gorge.
Can we carry on for a bit? Because this is, I think, this is some of the good
Please,
stuff.
this was
We've been waiting
entertaining.
for this for quite a while. And I don't know,
Great.
is that Rams that came in? You may be new round here. This is a long, ongoing discussion that we've been having. Very geometric, and this is about logical and arguments. Blue Marble's trying to present an argument. We thought we'd go over this, so give him a chance.
Notice that every one of them exceeds 180 degrees. The smallest is 15 minutes, 53 seconds, and the largest is 44 minutes, 33 seconds. So, now for the unavoidable truth. The zeniths are always doing this.
There you go. Always.
So the horizontals are always doing that.
Yep.
Now for the conclusions. The sum of reciprocal zenith angle measurements always exceeds 180 degrees, therefore verticals are measurably not parallel. Horizontals, therefore, can never be parallel. And Bev's assumption that all horizontals are parallel has been shown to be false. Well, there's conclusive proof that horizontals are not parallel.
So there's conclusive proof from Blue Marble Science that horizontals aren't parallel. Verticals as well. I'm not too sure he understands the consequences of that, the full consequences of it, but hey, let's pretend that horizontals still exist for a bit. Let's see where he goes from here.
All done and dusted. So let's move on to the fact that level is not horizontal, and we can prove that too. Let's talk about flagpole measurements. We probably all did this as a kid. You go out to the playground, to the flagpole, measure a distance away from it that you know. You stand there with a protractor and a string with a weight on the end of it. Get your buddy to read the angle as you line the protractor up with the top of the flagpole. And if you know how high the protractor is at that point, just a little simple math and voila, you get the height of the flagpole.
It's about the angle. I think they really like angles.
Yeah, they're everywhere, Bev.
There's something to do with the flagpole there. That's away from the place at A. But I'm pretty sure it's assumed parallel at that distance away in order to form.
Yeah, but still, if you have these flagpoles and supposedly they are on the same level, and you can't measure or see the drop because this farther flagpole is smaller. So if it lies on the same, let's say, plane or the same level, it is smaller, so it is dropping. So
yes, but paper, it is dropping. No doubt about it. That means angle alpha there is reducing because the size of the flagpole is appearing to drop. That's the perspective you're talking about. It's reflected in that angle. But at the same time, distance B is increasing. Look at the formula. Jesus God. Tangent alpha times B, that distance will give you distance C, and you add that to A and you get the height of the flagpole. That's how it works. This is simple geometry, simple trigonometry paper. You really ought to learn some of this stuff.
The angle would be smaller. This is how the objects are changing angular size in perspective while looking through lens.
But your distance is increasing at the same time, paper.
And
he's only measuring an angle, right? He's at school.
Yeah.
They're measuring angles to the top of flags. Like he
Yeah.
said, this is a schoolyard thing.
Yes, but still, but my point is that he is using this difference in angles as a proof of divergent verticals. But this
No,
is
I'm not.
well-known thing in perspective.
That is not what I'm doing at this moment. You're going to see what I'm doing very shortly, paper. Just shut up.
Without any divergence. It doesn't prove divergent verticals.
Is that not what you call stolen concept, though, right?
Yeah, completely, yes. So this difference in angles is from due to perspective only, solely. It has nothing to do with diverging verticals. So
that was a huge straw man. This has nothing to do with diverging verticals. You're going to see what it's got to do with in just a second.
Sorry.
If anybody's listening in, right, if you can spot the stolen concept within this that Blue Marble's about to do, and let us know. Postcards. Or just type it in the chat.
I love when he does.
They do that in reality too. Surveyors do this all the time. At times, all they're doing is trying to figure out how high a power line is over a road or something like that. But you can do it for other reasons too. And the interesting thing about it is this. If your baseline is mean sea level, for instance, it doesn't make any difference.
Anybody see anything there in the picture?
You see, I love when he does this.
Height of A. Looks like it's perpendicular.
He has nothing to say. He knows, he doesn't know what he's going to say. So he asks other people, do they spot the stolen concept?
Yeah.
He's fishing for ideas.
Yeah. Let's see what, I'm going to replay that and see. He said something in the background and I didn't catch it. Let's listen again.
Because
is that not what you call stolen concept, though, right?
Yeah, completely, yes. So this difference in angles is from due to perspective only, solely. It has nothing to do with diverging verticals.
And I didn't say it did.
So
paper.
Sorry.
If anybody's listening in, right, if you can spot the stolen concept within this that Blue Marble's about to do, and let us know.
Because Bev certainly can't find any stolen concept, and I'll tell you why he can't. There is not one.
Postcards, answers on postcard, or just type it in the chat.
They do that in reality too. Surveyors do this all the time. At times, all they're doing is trying to figure out how high a power line is over a road or something like that. But you can do it for other reasons too. And the interesting thing about it is this. If your baseline is mean sea level, for instance, it doesn't make any difference.
Anybody see anything there in the picture? You notice he's only got one height of A. A looks like it's perpendicular to both that line B and the mean sea level. Typical.
Where you put that theodolite, if that were truly a flat baseline, you can move the theodolite anywhere you want, and you'll still be able to calculate the correct height of a distant object like a radio tower. But because horizontal changes as we move over a curved surface, the trigonometric height, in other words, the calculated height of the tower above mean sea level, appears to change. The further away you go, the more it will drop. The closer you get to the tower, the higher it will be. And it's simply
Yes,
because this. That's
this
what
is
level
perspective.
is.
Yeah.
Yeah, say it again, Alan. Oh, saw you lighten up. I thought you were talking. Keep going with Bev.
Not, but he's depicting orthographic view, and now he is explaining how perspective works.
No,
And
that's
this-
not quite correct, because
Yes, it is.
If it's further away, the angle alpha will be smaller. So the tangent relationship is showing you the angular size due to perspective. And he's saying that if perspective is the only impact, then you'll be able to correctly calculate the height of the object above mean sea level just by using the angular size of the object, alpha.
Angular size of the object.
Yeah, so
the
alpha is the
equipotential
angular.
angle.
No, the alpha
that's
there
not, is
on a flat surface. Alpha on that diagram there is the angle to the top of the object, which you should be able to calculate based on perspective accurately. But he's saying you can't because there's an additional change in angle due to the curvature of the Earth.
Well, no,
so
it's not an
solely down to
additional
perspective.
change in angle due to the curvature of the Earth. It's an additional change in angle due to the equipotential angle of adjustment.
Which is down to the curvature of the Earth. Yeah.
It's down to the equipotential angle of adjustment.
Which on a globe is down to the curvature of the Earth, because
Just
the two are at
the
different.
difference between an orientation in one place and an orientation in another place. It's the angle between
Yes.
those two orientations. It's
Which
an
is
angle.
due to
It's
being
an
on a different
angle. Don't
Yes.
confuse people.
I'm saying what the cause of the angle is. It's because a different position on the surface of a curved surface.
No,
Sorry,
it's
different
because
position on a
it's
curve.
between two straight lines, as all angles are.
But the equipotential angle of adjustment is occurring because two objects have a different orientation because they are different points of on a curved surface.
No, those orientations, you've got to say they're straight, right?
With respect to what?
The orientation.
With respect to what? Orientation.
You're
is
measuring
a
an angle from one orientation to another. An angle is the measurement, the inclination of one straight line to another.
Yes, and
right. So those
between those is
orientations
down
are
to the
straight
curvature of the
lines,
Earth.
for fuck's sake.
Yeah, you seem to be confusing what I'm talking about. I'm saying that you're kind of saying I'm wrong, but then also explaining exactly the same thing.
No, you're
The
trying to
angle-
say it's a curve. It's not. It's an angle.
Well,
measured
unless these
between
things-
two straight lines. Those two straight lines
Due to the curve.
are the orientations in two different
And
positions.
that orientation is
on
due to being at
dogmatic
different
globe.
positions on a curve.
No, you are just adding this curve. This is imaginary curve.
No, it's an
It
angle.
does not exist.
It's an angle that you're adding, not a curve. Please don't equate an angle to a curve. It's just an angle. There's enough problems coming from angles and magic angles and all of that sort of stuff. It's going to be hard enough. Please don't try and equate an angle to a size and an angle to a curve. It doesn't work like that. You can't load too many things onto an angle. It's just an angle, for fuck's sake. Didn't do anything wrong. But have you spotted the stolen concept yet?
No, because there isn't one.
No? Shout out when you hear it.
When we reorient the theodolite like that, now we have a different horizontal. That's horizontal at the tower. This is horizontal at the instrument. So effectively, this is what happens. The tower now only looks like it's that tall.
Perpendicular. Maybe a little bit of a problem, but you've just got to add in the equipotential there, right? And then it's okay. You get it back again.
Well, in reality, we've got a real tower here. This is one from Larry Scott. This is not far from High Rock Lookout, about a mile.
It's got a height there, right? Obviously, they've built the towers for radio signals, so they know already how high the towers are. Of course they do. They know how high the mountain is. They want to know how far the signal goes, so they want to know, get it as high as possible so they can do that. So they know already the heights of this sort of stuff. But Larry does this as a hobby.
Or so away. There's a big red and white tower up there with a strobe on it. And Larry can see that thing from all over the county. Over a span of a few years, Larry has made measurements of that tower from a lot of different positions, 23 actually.
Angles. Larry has measured 23 separate angles. Let's give him a round of applause, right? Larry's special. There's not many people that do this, but Larry dedicated to this.
Whenever he found a place where he could see the tower, he would stop when he had time, get out his theodolite, and take some readings.
He's like, what's he doing? It's that dude that likes to, whenever he sees the tower, he has to measure an angle to it.
It's a plot of all the positions Larry measured from. I've shown the longest one there. You see the tower in the lower right.
Look, he records where he is. He's measuring an angle to that tower. He likes it. I think the tower's always the end point of his angle measuring. Don't think he ever starts at the tower. It ends at
really an autonomous
He
attack
got one
here.
measurement from 27.7 miles away.
27.7 miles. It's a long one.
Here's all the data.
The
top number is the elevation of the tower that Larry was able to calculate, not the FAA elevation. This is Larry's calculation based on all of his measurements. And it's within a...
So it's not the official. Larry doesn't go with the official one.
Just hang on, Bev.
Does it for testing himself.
Few feet of what the FAA says. But there's something interesting here. Notice the very first measurement was from 27 miles, and his instrument elevation was 1961. He's about 390 feet lower than the tower. Oddly enough, he's having to look down to see it. Now figure that one out, Bev. Figure that out. His instrument elevation is below the tower elevation, but he's having to point the theodolite down to see the tower. How do you think that happens on a nice flat plane? I'll tell you, it doesn't. You can't possibly have that. That is impossible. You see in the right-hand column all of the tower height calculations that Larry made, and they're all over the place. That's because that is the calculated height of the tower without considering Earth curvature. When you plot that data, it looks like that.
See, that looks smart, that, doesn't it? Look at it. That's that's what you'd expect to see for your rumpus pole graph.
That's an 8 inch per mile squared per 8 inch drop, in effect, times distance in miles squared. That's exactly what that is. Well, you got to take refraction in there too, so it's less than 8. It's I think about 6.75 or something like that. But whatever, that is the typical curve that we always see over distance, and it's due to Earth curvature.
I think like all of these distances here, like I call them verticals on this graph, but I don't know whether that would be the correct term to use. But that would be the length of your rumpus poles, measured like that on the graph. He's done well graphing it.
You see that pretty curve? It's almost a perfect fit. R squared on that data is 0.9999. I decided to take a look at a couple of points. That point and that point. Well, you can see.
Have a look at him. Look at him. Blue's put circles round him. He's having a look at him.
I thought it might be nice to tell you which 2 points I was looking at, Bev, so I put circles around them. Why is that a problem for you?
Focusing in on those points. Look. It's done all the numbers for it and everything. It's focusing in on them.
See that at the distant target of 27 miles, the predicted drop's 431.3 feet. The measured drop is...
Remember, this is Blue Marble doing this for a debate. He's done all of this himself, hasn't he? It's like it's a pity he couldn't do it live. Almost as if. You'd think that Blue might have actually done this himself, wouldn't you? Not just going off a story that Larry's told him.
434 feet. That's 2.7 feet difference. It seems to be fitting 8 inches per mile squared pretty well with refraction. Same thing on that center point. 145.7 is the predicted drop based on my calculation. 144 feet is what Larry got. That's 1.7 feet different. Larry went ahead and took...
It's 1.7 feet different. Blue calculated it and Larry was 1.7 feet different than what Blue calculated.
all that data and applied both curvature correction as well as refraction correction, and you end up with a straight line, nearly perfectly straight.
End up with a straight line.
Yeah, Bev, that's what happens.
Nearly perfectly.
Plot it. Yeah.
That's what happens when you take 8 inches per mile, or 8 inches times miles squared.
So it's
and refraction
plots it all. If you do something with those curved lines and do it, you get a straight line.
You get the tower elevation,
Yeah,
Bev.
I think he did say you had to measure an angle down, Mike. Yeah. Measure an angle down. I don't know whether you said below or not. Do you want to just check?
You got one measurement from 27.7 miles away. And here's all the data.
There we go.
The top number is the elevation of the tower that Larry was able to calculate, not the FAA elevation. This is Larry's calculation based on all of his measurements. And it's within a few feet of what the FAA says. But there's something interesting here. Notice the very first measurement was from 27 miles, and his instrument elevation was 1961. He's about 390 feet lower than the tower. Oddly enough, he's having to look down to see it.
Having to look down to see it.
Yeah, Bev, down.
Yeah.
He's at a... That's really important. That's significant, Bev. Don't try to dance past it. He has his instrument at a elevation which is almost 400 feet lower than the tower. But in order to shoot the top of the tower with a theodolite, he's got to angle the theodolite down, below horizontal. That can't happen if the earth is flat, buddy. You see in the right-hand column
300 foot.
all of the tower height calculations that Larry made, and they're all over the place. That's because that is the calculated height of the tower,
So
not more than 3 feet apart. So that's earth curvature you're seeing. That is level deviating from horizontal. But we can do that with just observations, more than as refraction is what Larry got. That's 1.7 feet different. Larry went ahead and took all that data and applied both curvature correction as well as refraction correction, and you end up with a straight line, nearly perfectly straight.
You do curvature correction to your data to end up with a straight line.
Yeah, Bev.
Really?
Almost any.
That's handy.
Almost any half-wit would be able to understand what I just said. That raw data is including the effect of earth curvature in it. If you want the actual elevation, you've got to take that out. You've got to take that and refraction out of it. And when you do that at the published rate, the numbers that we always use for refraction and curvature, the line goes from curved to straight. The elevation of the tower is the same then, no matter which one of those points you pick. We know the elevation of the tower doesn't change depending on where you are. It can't. So the original curve, without any correction made to it, makes the tower change size depending on how far away you are, or it makes it change elevation depending on how far away you are. That's ridiculous. You know that's not happening. This is how it's explained. It is the effect of refraction and curvature.
I suppose it's easier to deal with straight lines, isn't it? Correct, yeah.
That straight line is just the elevation of the elevation of the tower, Bev. Taken from each point after it's corrected for curvature and refraction.
Curves into straight lines.
Notice that vertical scale. Those blue dots are not more than 3 feet apart. So that's earth curvature you're seeing. That is level deviating from horizontal. But we can do that with just observations too.
That's level deviating from horizontal when you do the curvature corrections to make a straight line. I think.
Here
we go.
An auto level is a great device. We set an auto level up. It establishes vertical by referencing itself to gravity, and it makes a horizontal plane of reference for you, which is 90 degrees to the vertical. That horizontal will extend all the way to infinity, but in reality, you're going to become limited by what you can see through the atmosphere. Now, if the reference surface were flat as that's being shown, that horizontal will always be the same distance above the reference surface, always.
Always.
If it's 5 feet at the theodolite, 30 miles away, it will still be 5 feet above that flat surface. The problem is, that's not what the Earth looks like. The Earth looks like that. And the gravity vector is different, and horizontal is different, as we've already seen. So let's move on to an observation that Bev really hates, and it's Blackpool Tower.
So I thought he was about to show us here.
Not more than 3 feet of surface, always.
I was waiting for the rumpus pole. I was waiting for him to tell us to do the reciprocal rumpus pole, but it may have been. This is a bit a while ago, right? So he's obviously focused on only the single.
Yes, but he stated one important thing. He said that this distance between horizontal and level, I think, or maybe you can put you can rewind a few seconds when he's saying that, because I don't want to misrepresent what he said.
Okay.
If it's 5 feet at the theodolite, well, why stop misrepresenting me now, paper? That's all you've done. 30 miles away, it will still be 5 feet above that flat surface.
Yeah.
The problem is, that's not what the Earth looks like. The Earth looks like that.
Yes.
There you go. Do you want to carry on a little bit more, or are you okay with that?
It is okay. This is what he said. This is essential. So he's saying that this 5 feet difference between level and horizontal would be at the 30 miles or whatever distance would be 5 feet. So of course it means implies that if level is curved, it means that horizontal has to be curved also.
No, it doesn't. Where do you get that bullshit from, paper? How in the world did you get that one?
But nevertheless, he is saying that this is not like it how it looks like. So he is referring orthographic, let's say, picture, so reality, with what we see through theodolite, so with perspective. So he's confusing, because of course this is an important point, that we see things in perspective differently than they are in reality.
5
So
feet.
things that are at the same height, in reality, this 5 feet, they are not at the same level in perspective.
Paper, 5 feet is 5 feet. If that is truly a horizontal plane, 5 feet above it is 5 feet above it everywhere. If that auto level is projecting a horizontal plane of reference at 5 feet at the instrument, it is going to be 5 feet anywhere you measure it, as long as that plane of reference is flat and horizontal, as you guys maintain it is. That's what I'm saying. And your perspective argument doesn't make any sense at all. Perspective does not have anything to do with that. You can't change the height of that horizontal line. It has to always and forever be 5 feet above that reference horizontal plane.
Yes, yeah, but he's not. They're not bothered about perspective or anything like that, right? What he's done. There's a shadow giant that's sadly no longer around, right? Jesse Kozlowski. Jesse Kozlowski said that level drops from horizontal.
Well, he said that because it does, Bev. Level drops away from horizontal in every direction.
So exactly like Blue's showing there. It drops away. It goes down. Drops down, like Jesse said. It drops away, drops down from
Certainly
horizontal.
does.
And that's exactly what you're seeing in the picture there. That's why Blue's doing it. Shadow Giants told him.
Yes, I know.
Can I just add one thing? No, sorry, Paper. Just let me add one thing real quick. Our vision ramps up, yet they're saying it's going down.
No, they're
But our
saying
vision
level drops
ramps
away
it
from
up.
horizontal. Like, look.
Yeah, but when you look through the tool, it's ramping
No,
up.
you're not talking about that. We're just talking about Blue's argument here. He's showing that level drops from horizontal. It's there in the picture. You don't need to read anything else into it. Like, don't be clouded by what you might be seeing, right? Jump in my shoes, right? We're seeing this from the first time.
Yes, he's not showing perspective view, what we can see through theodolite. He's showing orthographic view. So, like reality.
Well, you're going to see it in a minute. He's going to go and show you. He's seen a picture. He's seen something. And that's where he goes. So here we go, look.
And the gravity vector is different and horizontal is different, as we've already seen. So let's move on to an observation that Bev really hates, and it's Blackpool Tower.
Right, now, he says that I really hate this. Well, you can see me in the picture. So, I'm not too sure I really hate it. But you can see me in the picture, right? That means that a camera has been fitted to an auto level, invalidating the tool for any surveying purposes.
Why?
And that screen has been broadcast into Discord. And this is the video that's resulted from it.
One day you're going to have to explain to us why aiming a camera through an auto level invalidates the tool. What is it that the camera is doing to the tool to invalidate what's coming through the lens of it?
So Blue's going to do that. But I mean, this is the actual thing that you would see. Well, not actually through an auto level, but it's what you'd see if somebody strapped a camera to the back of an auto level. And
wait a minute. So you don't see the same thing with a camera that you see when you look through the auto level with your eye. That's what you're saying. How does that work, Bev? Maybe you could explain that to us one day. Why does the camera not see the same thing you see?
Broadcast the picture into a Discord. this is exactly what you would see.
Yeah, but according to Blue Marble science, your height is nearly the same as Blackpool Tower height.
No, that's
So
not
you're-
according to Blue Marble science. That's not at all what I said. Bev's only a few hundred yards away from the auto level. Blackpool Tower is 13 miles away. Come on now. You know, the straw man thing is getting a little bit old, paper.
You have, I don't know how high
Well, I
is
think that's
Blackpool
about
Tower.
100 feet. That bit.
Yeah,
of
so
the
Bev
Blackpool
is very tall man.
My
Yeah.
hat is around about the same 100 feet. You know, like if I was in Blackpool, I'd be a few stories high, according to that, or whatever. I mean, but that is like, it is just a camera on the back of an auto level. That's it. I don't know why Blue seems to think. And also, see the picture on the left, the one that he's got of Blackpool Tower. Well, that's taken from out in the seafront, at the front of. It's a completely different angle. It's a lot closer. It's just a picture of Blackpool Tower. Blue does this a lot. He likes to just do association things. So this is what this is. It's just a picture of Blackpool Tower, just so you know that this is Blackpool Tower. He likes to think that there's some other associations, but I mean, there isn't really. And like, yeah, well, let's see what he says.
Bev's auto level is set up, and the crosshair is just a few feet above sea level, probably less than 10. Google Earth says that beach he's standing on is at sea level. But look 13 miles away.
So he knows where we are, right? The actual beach is sea level. That's interesting, isn't it?
At Blackpool Tower in the distance, and the crosshair is 100 feet up on that building. I'm going to fade in a picture of the actual building. There's the crosshair. There's a red reference line. Now watch the building. I'll fade it back out. Keep your eye on it. And the match is almost perfect.
Almost perfect, Blue, and he's blending Blackpool Tower in and out.
Same thing we see in Bev's photograph. That's where the crosshair is striking that building. And that is about 95 feet above sea level. So that's reality.
Right, so I mean, let's see where
We have an auto level that's establishing a horizontal
It's
plane of
lovely, but
reference.
That's what we've seen.
We got Bev in the foreground,
Yeah.
just 400 or 500 yards away.
Camera on his auto,
But we got Blackpool
validating it.
in the distance, 13 miles away, and that 5-foot high auto level above that beach surface should be striking Blackpool Tower 5 feet above sea level, if level is horizontal. Problem is, level is not horizontal. The auto level crosshair is on Blackpool Tower at about that point.
Hey, look. See this?
That's because that's what the Earth looks like.
So, what you can
Tool
see
abuse.
here is, well, I mean...
No, I'm sorry.
No, there is
Tool
a,
abuse.
there is a problem, right? This is why we're going to go to Bedford and do the reciprocal, right? Because it's never been done. How do you know, from looking at this, that Blackpool Tower isn't just lower?
What? How do I know Blackpool Tower isn't just lower? Bev, are you saying that sea level dropped by 95 feet over a distance of 13 miles? I don't think you really wanted to say that, did you?
How'd you know? It's
I know, but
it's down. It's just
this is-
lower, isn't it? Obviously, it's got to be. It's a drop from horizontal.
This is just what I call perspective drop, and this is normal thing. So I don't relate that into with any curvature of the Earth or whatever.
Oh, it's obvious that the Blackpool Tower's below, right? Blackpool, at least from looking at that from Southport, like Blue Marble says, the armchair geodetic surveyors looking at pictures from invalidated tools, obviously, and looking beyond the range of the normal ones, and doing some little bit of blending with the camera work and all that.
And excuse after excuse after excuse, huh, Bev? Any port in a storm, I guess, huh?
But I mean, look at it. It's below. It's a drop from horizontal. How do you know that Blackpool just isn't lower?
Bev, you have said some absolutely stupid things over the last few years since I've been listening to you. But that's got to be about the dumbest fucking thing I've ever heard. That's even dumb for you.
So what you're suggesting, just to make it clear, is that the reported elevations are wrong.
Okay. Well, no, I mean, like, look at Blue's picture there, right? Blackpool Tower obviously is lower, isn't it? Down.
Yeah,
just
you're
like
saying
Jesse
it's obviously
Kozlowski
lower,
says.
right? But we have information on, or at least claimed information in literature about the elevation of Blackpool Tower.
Yeah, we do.
The height
Of course we do.
Yeah. And what
Is that Morty Master?
All of the it is. Well, he doesn't. He can't remember ever being Morty Master or any of those other characters that he sounds exactly
Welcome
like.
back. Right?
Yeah. So I mean, it's below, right? Even Blue says, I don't know how many feet down, but that's obviously what they're doing.
What you're saying is it's obviously lower.
Yeah.
Right? And you're asking.
Are you not saying it? Do you not think it's lower?
How you're asking the question? How do you know it's not lower? And I would say, well, how high it is, you would know by the elevation information. So what you're implying is that elevation information is wrong?
No, I'm looking at what Blue's doing with this brand new Blue Marble armchair geodetic surveying, right? Where they take a picture of they got off the internet, because there's a camera strapped on the back of the auto level, and I think you'll hear us say many times that invalidates the tool.
Why?
But I mean, they never listen. But this is a new Blue Marble geodetic surveying technique.
Yeah, well.
Yeah, and they make sure that Blackpool Tower is definitely below, right?
Wow.
But how do you know it's not just below? You need to do a reciprocal, don't you?
Blue, I think this is absolutely freaking amazing. They're basically showing that the Earth is curved. They're admitting that Blackpool Tower is lower, and yet it's because you look through a camera attached to a theodolite instead of looking through the eye. If you look through the eye, you'd see the same damn thing and report this.
It's amazing. I mean, you from time to time, you see a guy shoot himself in the foot. But Jesus, this is as bad as it will ever get right here.
He's basically showing and admitting that sea level, that the tower is lower, but yet it's 95 feet above sea level. What happened to the other 90 feet, Bev?
Where did it go? Where did that distance go, Bev? I mean, you can't be saying that Blackpool Tower is 95 feet under the water. We know that's not true. What in the world went through his mind when he came up with that one?
So the only thing they can say is that the measurement's invalid because you're looking through a camera instead of looking through the eye, because apparently theodolites are not designed to be taking pictures of. I guess.
I still want to know what the camera sees is
it has
different
to be
than
that
what
way.
you see.
Well, it has to be that way. Otherwise, the Earth is round, and we can't have that. So there's got to be something.
Yep. Wow.
This is a new low even for Bev.
Oh, I'm telling you that
is. As you guys down south say, he's taking a bunch of stuff and throwing it against the wall and seeing what sticks.
Yeah, but God, I would think you would think he would come up with anything other than this nonsense.
He's got nothing else. This is it. I mean, he has got nothing else. His only other option is to admit that the Earth is a sphere.
Yeah, I think that'll be my next meme. Is that picture of Bev and his quote? How do you know the tower's not just lower? Wow, Bev. I mean, that leaves me speechless. Absolutely. I've heard some dumb shit in my life, but that is right up there with the best of it.
To check. Well, that's why we're going to Bedford to do the reciprocal rumpus pole sighting. To make sure that the drop occurs both directions. A reciprocated drop.
Okay.
It's not often you get a chance to watch a guy whip his own ass this thoroughly, is it?
Okay. Okay. Thanks.
Thank you. Mike Jones says, Blue imagines you're 50 foot tall, Bev. Thank you very much. Yeah. I'm only little. I think they all know that.
You can put it both ways. Or Blackpool Tower is, let's say, as small as you, or you are as big as Blackpool Tower. So, or you have like 50 foot, or Blackpool Tower is, let's say, 5 or 6, or whatever height you are. So you can have both ways. But this is just misrepresentation of perspective.
Have you noticed the one of the laws that he's not breaking, the stolen concept? You might not be noticing it because he's doing a good way of tricking you with it. But it's still in there. Shout out if you hear it, see it. There we go.
That's horizontal, that's level, and they're not the same. Predicted drop is about 95 feet. And that
95 feet drop. Everybody knows what drop is, right? Down, below. You have to fall in order to get a drop. Unless he's talking about a rumpus pole. But again, I'm not too sure. Hard to tell. But he does say 95 foot drop down, below, like Jesse Kozlowski says. We haven't reciprocated it, so obviously. Since we were there, right, to show people that over 500 meters, you can't measure an angle of an arc second.
You're looking through an auto level, Bev. You can't measure an angle with it, period, you dumbass. It's an auto level. It doesn't measure angles.
Can't see it. An arc second in that picture is 3 millimeters. Could you measure to that as your tolerance through those sights? Do you think you really could with an auto level? It's got better scope than the guy that lied about measuring angles at that accuracy. That's what we went there to go and show people. And that is valid to be able to show people through an optics thing, to show people what you could see through these optics. That's why we put a camera on the back of the auto level, not to actually do any surveying with it, just to show people. But 95 foot, well done, Blue. Nicely done.
That's just about exactly what we see there.
Apparently, you can't put a camera on an auto level, though, and that's okay, but you can't put one on a theodolite.
Well, yeah, you can put one on the auto level if you're looking at a grade pole. Yeah, that's what you just said. Perfectly fine if you're trying to read the numbers on a stick, but it's not okay if you're looking at something in the distance. I don't know why. Bill's got his own rules. And they seem to change too, don't they?
The rules seem to change depending on whether he's doing it or whether you're doing it.
Yeah, right. Exactly.
Okay, let's see how we do with the excuses.
So now for the excuses. Well, I know what Bill's going to say. He's going to say they were just taking a picture of the measuring rod and the tower happened to be in the background and mean old Blue's not playing fair.
I don't know about playing fair. Just wondering why you're doing it, but
I'm doing it to make you look like an idiot, Biv. That's why I'm doing it. Or he's going to tell us that the auto level has a maximum suggested working range, which is true if you're trying to read a measuring rod, but we're not trying to do that.
No,
What I'm doing is looking at where it's striking that building in the distance.
yeah, he's imagining Blackpool Tower as a rumpus pole, I think.
Yeah, strange.
Yeah.
This is strange.
Like I said,
Like we know the elevations of every part of Blackpool Tower, Biv, and it is absolutely as good as a measuring rod, just not with that kind of accuracy to a few millimeters. But you can certainly use the height of a known object in the distance, just like you use a measuring rod. There's absolutely no difference in those two things. All you have to know are the elevations of various points on the thing that you're looking at. Works the same way as a measuring rod does. I don't know what's wrong with you.
say this isn't like Blue says, right? It's got a working range. We're not dealing with that tool, right? We're extending the range with the new Blue Marble geodetic surveying, armchair surveyors. It gives you an ability to use objects in the background to be able to do this.
Actually, what it boils down to is reasons.
Reasons.
So what conclusions can we come to? Level clearly and measurably deviates from horizontal over distance, and it does so at a rate of 8 inches per mile squared.
That's what Jesse Kozlowski said. Drops down, drops away from horizontal at a rate of 8 inches times the distance in miles squared. That's Jesse Kozlowski's words. Blue's just parroting that.
We've proven that.
Well, I wouldn't say proven.
This effect can be confirmed both qualitatively and quantitatively.
Whoa, this effect.
We've just shown you that.
It's an effect now. That's not really fair. That's a bit of sophistry, right?
Yeah, visual effect. Yes. So
It's
now
an
he is
effect.
talking about a perspective. So
He said he's
visual
proved it,
effect.
but now it's an effect. How can you
No.
prove an effect? I'm not too
Yes.
sure Blue knows what he's talking about. Maybe a slip of words, right? Maybe he said the wrong thing. Maybe
Or
one of his
maybe not.
intentional mistakes. Who knows?
Maybe I said what I meant to say, Bev. Did you ever think about that?
You never know. He does leave a lot of mistakes in so everybody can find them.
And Bev's assumption that level is horizontal is absolutely false.
It's not an assumption, Blue. It's not an assumption.
So I got one final question, Bev.
One final question.
You still think this was a good idea?
Absolutely.
Hey, thanks for watching.
Yes.
All right. Well, that took us through only about half of Bev's video. And we've been going now for 3 hours and 47 minutes. I'm not going to do another 3 hours and 47 minutes of this.
Oh, you can't handle another 3 hours and 47 minutes of Bev?
No, I don't think so. And I don't think anybody else can either. I really don't. But hey, I appreciate everybody showing up today. I hope you had a good time watching this nonsense. Bev has really, really put his foot in it this time. That tail end part of this, I almost wanted to show that first, but a lot of people were still hanging around, so hopefully.
Who's the guy who kept saying it was just perspective?
Oh, that's the paper organist.
Wow. He has lemon optics nailed.
Yeah, yeah.
Anything other than curvature, has to be perspective.
Yep.
Perspective in this case.
Yep, exactly. So, I think Bev managed to completely discredit himself there at the end of this thing. There's not a whole lot left for me to do other than just thank everybody for showing up and we'll do this again. Hope everybody has had a good Memorial Day. And
it rained all weekend here. Now it's finally 6:15, 6:30 at night, and the sun finally comes out.
yeah, right. The shout out to Turing Test 2 for 10 pounds. Thank you, Blue. Well, thank you, sir. I really appreciate that. And I'll tell you what, with that, I'm going to say goodnight and shut this stream down. We'll see you guys on the next one.
Night, Blue. Have a good time. Have a good what's left of the holiday.